Hello everyone, my name is Abhishek and welcome back to my channel. This video aims at explaining the networking concepts right from the fundamentals. Even if you don't understand what exactly is an IP address, you can go ahead and watch this video. This is a 3-hour long video. I broke this video down into 5 chapters, and using each chapter, you will learn networking concepts. And towards the end of these 5 chapters, you will implement 2 networking related projects on AWS. So you will not only learn the networking fundamentals, you will learn advanced networking concepts on AWS, and you will be able to implement a 2-tier architecture project, as well as you will learn advanced networking concepts such as security groups and NACLs. So what are you waiting for? IP address. IP address is a very simple concept. So IP address is used to generate or to provide a unique address to a particular device that is connected to your network. Don't worry, I'll make it simple. Let's say you have a home network. There is a house, and within this house, there is a Wi-Fi or local network that is created through a router. And there are 2 people or 2 persons living in this house, and each person has 2 devices. So overall, there are 4 devices that are connected to this local network or the Wi-Fi network. Now, what happened was one of these devices was used to connect to a payments website and made a payment. You want to track which of these devices was connected to this payment device, and you want to block access in the future. Probably also there is a kid in the house, and you might want the device that is used by the kid to access Instagram, or you might want one person who is using this particular device to block access to youtube.com. Now, if each of these devices does not have a unique identification number, how can you do that? Right? It's practically not possible, and you will end up doing all these devices access blocked to these websites. So to avoid that, each of these devices should have a unique number, and that unique identification is nothing but IP address. It's not just about blocking access. Probably you want to track the activities of a particular device, or you want to monitor activities of a particular device. In all of these cases, IP address comes into handy. Now your next question should be, Abhishek, okay, I understood IP address is a unique number that is given to device. Let's say in my house, if there are 4 devices, each device gets a unique IP address. But my next question is, how does this unique address look like? So you said this is a unique address, but how exactly does it look like? So just like human beings have names, or houses have the house number, which are unique, right? Of course, human beings' names are not unique. But if you take about houses where you have a unique identification number for each house, so this particular representation is done through IPv4 for devices. There is also a standard called IPv6. We'll talk about it later. But for generating unique address for each device, the standard that is followed is IPv4. And using IPv4, you can generate huge number of unique addresses. Now, why is that required? You might say that, Abhishek, why do I need to follow this particular practice? In my house network, there are only 4 devices. So I can simply say one device as 1.1, one device as 1.2, third device as 2.1, and fourth device as 2.2. Now, each of them got unique identification. But what if there are 10 more devices that got added? Or instead of this house, let's take example of your school or your university, where there can be 10,000 or 20,000 devices that are connected to a particular number. So for each of these things, to maintain a proper standard, see, for your house, if you maintain this particular standard, so for your school and university, you have to create a different standard. So to maintain a proper standard, the one that is used is IPv4. So using IPv4, what you will do is you will generate a unique identification number in the format such as 172.16.3.4 or 10.1.2.4. So these are the IP addresses. That is, if you are using IPv4 standard, for your device, you will see addresses in this particular format. Today, you can go to your laptop and type the command called ifconfig or ipconfig, and you will see this kind of representations for your device. Now, these things are called as IP addresses. Now, let's try to understand what is the significance that you get when you assign this kind of numbers. So if you watch carefully, for each number, there is a dot, right? So here there is a dot, here there is a dot, here there is a dot, and here there is a dot. What is the advantage? So the advantage that you get is each of this number can vary from 0 to 255. So that means the number of unique identifications that you generate varies from 0 to 255 multiplied by 0 to 255 multiplied by 0 to 255 multiplied by 0 to 255. So this is the number of unique IP addresses that you can generate using IPv4 standard. Now your next question has to be, Abhishek, why 255? Why can't it be 0 to 1000? So with IPv4 standard, what you do is, of course, this is a number that you see, but for computer, it does not understand numbers. It only understands bits. So each of this number is 1 byte or 8 bits, right? So overall, what exactly is an IP address? IP address is nothing but 4 bytes or 32 bits. And each byte, right? 4 bytes, each byte is separated by a dot. So how does an IP address would look like? IP addresses would look like 0 to 255, 0 to 255, 0 to 255. Got it? So why 255? That is because in computer language, in IPv4 standard, you have 4 bytes and 1 byte is nothing but 8 bits. So 4 bytes is nothing but 32 bits. So overall, each of this number that you can see can be varied from 0 to 255 only. So this is a standard, you cannot change it. And this standard is called as IPv4, if I repeat one more time. Got it? So how does IP addresses look like? So tomorrow, if you create an EC2 instance or a virtual machine in Azure, what are the numbers that you would usually see? You will not see something like 600.400.150.10. This will not be possible. Numbers that you would see can probably be 192.168.12.14. Any number in all of these 4 places that is separated by dot should be varied from 0 to 255 only. I know I'm repeating this multiple times, but I want to make sure you all understand how the IP address is represented. It is only represented between 0 to 255. That is because in computer language, IPv4 represents IP addresses in 4 bytes, and each of the byte, right? Each of the 4 bytes is nothing but 8 bits, right? And how are these 8 bits represented? If I have to write this IP address, I have to write 32 hyphens, for example. Okay. This is 1, 2, 3, 4, 5, 6, 7, 8. This is 1 bit. 1, 2, 3, 4, 5, 6, 7, 8. This is another bit. 1, 2, 3, 4, 5, 6, 7, 8. This is another bit. 1, 2, 3, 4, 5, 6, 7, 8. This is another bit. So this is byte 1, byte 2, byte 3, and byte 4. So this is how IP addresses are represented. Now, when I say 192, what happens is, how does computer understand this 192? Computer understands this 192 as 1 1 0 0 0 0 0 0. Now, how did I write this particular thing? That is very simple. For each byte, each bit that you see here, you start with 0, you call it as 2 power 0. This is 2 power 1. This is 2 power 2. This is 2 power 3, 2 power 4, 2 power 5, 2 power 6, and 2 power 7. Because the first number is 192, 2 power 7 plus 2 power 6, that is 128 plus 64, which comes to 192. This is how computer understands your IP address. The reason why, maximum number that you can see here, right? If you want to see here, even if you put 1 1 1 1 1 1 1, computer understands this as 2 power 0 plus 2 power 1, 2 power 2, 2 power 3, 4, 5, 6, and 7, which combinedly comes to 255. That's why maximum number in an IP address can be 255 only. If you see something like this, 192.600.12.254, this is not an IP address because 600 is not possible. Now, I hope it is very clear how IP address is represented in the IPv4 format. Now, if you want to try out few IP addresses, you can give it a try. Like, your assignment can be convert this particular IP address, that is 172 probably dot 32 dot 16 dot 1. Convert this IP address into the format that I have explained. That is using the bits format. How does computer understand this particular IP address? So to do this, what you will simply do, you will convert each byte into 8 hyphens. You will write 2 hyphens, and under this 8 hyphens, you can write 2 power 0, 2 power 1, 2 power 2, 2 power 3, and convert this particular thing. Let's say if I have to write this, by default, I know 32 is just 2 power 5. So this is first decimal, second decimal, third, fourth, fifth, sixth, seventh, right? If I have something like this, in the fifth place, I'll just put 1, and in all of the places, I'll put 0, right? So this is how IP address is converted in the hexadecimal or octet format. It's octet format, it's not hexa. So this is how number is converted into octet format and how computer understands the IP address. Perfect. Now you will understand later point of time why I'm stressing so much on this particular representation. When we try to understand subnets and CIDR, this comes very, very handy. So I hope IP address part is clear. Now let's move to the next concept, that is subnet. Now, Abhishek, IP address is very clear, where let's say if I have a home network or a school network, and within the school network, what I'll simply do is I will say I just need some, whenever I'm creating this particular network, let's say I'm creating a VPC on AWS or I'm creating something on OpenStack. Okay, so I'm requesting the network provider, let's say some 65,000 IP addresses, and I got 65,000 IP addresses. I know the maximum people that would connect to my network, if it is a school network or office network, maximum people that would connect to it is only 40K. So I've just taken 25K IP addresses as a space. So I know, okay, this amount cannot be exceeded. Now I'll create a school Wi-Fi or office Wi-Fi, right? Let's call office Wi-Fi, and we will call this office Wi-Fi as free Wi-Fi because anyone can connect to it. So any new employee that is joining this company has started accessing this network, right? This person, this person, this person, everyone has started accessing this free network. Now, what happened one day was there is this employee who accessed a malicious website. Okay, so this person has accessed a malicious website that was written by a hacker. And because this person has accessed it, hacker got access into this particular device. And now if you understand carefully, all of these devices are connected to the same network. That means hacker got access to one device, but because they are connected to the same network, hacker can access all the devices, right? So technically all the devices are hacked. Now, if this is your office network, there can be some sensitive files, or there can be payroll of the employees, or there can be some financial data of the company that are stored in some servers, such as your bank details or any such thing. So hacker got access to everything. So your complete company network got hacked. Now this should not happen, right? Of course, this should never happen. So there is a concept in networking which is called as subnet. What exactly is this concept of subnet? Very simple. Subnet is basically, if you look at the name itself, it says sub networking, where if you take the same example, you can create a VPC in AWS, or you can create a new network on your OpenStack with 65,000 IP addresses. And what you will simply do is you will say, out of this 65 IP addresses, okay, or out of this complete network, I will split it into two parts, okay? And one network I will use only for finance related things, all the sensitive information of the company. I will call this network as secure network. Like sometimes if you go to your company, or if you go to your school network, you will see some secure networks which you don't have access to. And then you will have some free network, or this network can have a password, but this will be shared. If you are an employee, you just go to your admin and you ask for a password, and they will share this password with you. So I'll call it as a free network. And so I will try to split this network into two parts. And I will say network one should be strictly used by finance team, and network two can be used by anyone. Now, even if the hacker, one of these people, tries to access a malicious website and hacker gets access to it, all the devices in this particular network are compromised, but still all of these are sensitive. This is important for the company. This concept is called as subnetting. And this particular network is called as subnet, and this particular network is called as subnet. Why are they called as subnets? Because they are part of a bigger network and you have tried to split it. So that's why you call it as subnet, right? Understood the advantage of creating a subnet? The advantage of creating a subnet is you get security, you have the privacy, and you have a proper isolation. That's why subnets are used. Today, you can go back and you can create subnet in your home Wi-Fi network as well, right? You can say only the heavy usage appliances should use a particular subnet, and other appliances should use a different subnet. That's totally possible. You can create subnets in any kind of network, right? So this will give security, privacy, as well as isolation. Now, I'll come back to the concept of subnet addresses, like how subnet 1 gets IP addresses and how subnet 2 gets IP addresses. But before that, just understand that there are two types of subnets. One is private subnet, two is public subnet. If you ever used a cloud provider, you might have heard about these terms called private and public subnet. But what exactly are these? So private subnet is some network that does not have access to internet. And public subnet is a subnet that has access to internet. That's the only difference. It's a very simple difference, right? So private subnet has access to, does not have access to internet, and public subnet has access to internet. How do you do that? How can you enable access to internet? Don't worry, it's a very simple concept. If you already know about cloud providers like AWS or Azure, all that you need to do is you can go to this particular subnet and you can attach route tables to this particular subnet, and destination of a particular route of the subnet you can provide as an internet gateway, and that will grant access to the internet. Even if you don't know this particular concept, you can ignore for now, because right now we are learning the fundamentals of networking. So just understand access to internet, public subnet, no access to internet, private subnet. Now let's go back to the concept that I was explaining, right? Abhishek, you mentioned in the last slide in a very simple way that you have a office network, right? And in the office network, you said you will simply split finance and free subnet where everyone can join. You mentioned it as very simple way where there are 65 IP addresses, but how do you actually know how many IP addresses this finance subnet gets and how many IP addresses that this particular subnet gets, right? Overall, when you created this VPC in AWS, you have requested for 65,000 IP addresses. What is VPC? VPC is just nothing but a private network. So you have requested for a private network from AWS and you said you need 65,000 IP addresses. Now you are saying you will create two subnets in the 65,000 IP addresses. One is finance and two is a free subnet. Everyone can access. But how will you say that this finance subnet, let's say it only needs 256 IP addresses and this need rest all IP addresses? How will you divide that? It's very simple. Again, wherever you are creating this subnet, right? So if you are creating on private cloud, you have platforms like OpenStack. If you are creating on public cloud providers like AWS or Azure, in any of the cases, whenever you are creating this subnet, you will be asked to provide a CIDR range. This is also called as CIDR. So this CIDR or CIDR is a way of explaining how many IP addresses are available in a particular subnet, right? Here I want to say my finance particular thing just needs 256 IP addresses and rest all can be given to this free subnet where anyone will access this particular network. Now, how will you do? CIDR is the solution. How does CIDR work, right? So concept of CIDR is very, very simple. Don't worry, I'll explain it in a very simple way. People usually find it difficult, but the calculation is very simple. So what you will do when you create this particular subnet, let's use AWS as an example. So you will go to AWS and you will say, I want to create a subnet. Of course, you need to go to the VPC first, right? This is the VPC that you have initially created. You will go to this VPC. Inside the VPC, you'll go to the subnet. And within this subnet, what you will do, I mean, you are creating this subnet. When you are creating, you will be asked for a CIDR. And when you want to create this CIDR, the simple solution is you say 172.16.3.0/24. So if you require 256 IP addresses, you will provide -24. Now, how did I do this? Right? This should be your $1,000,000 question. That is, Abhishek, how did you understand if I need 256 IP addresses, I need to provide 176.16.3.0/24 or 192.16.4.0/24, whatever is the IP address of the VPC followed by /24. How did you understand this? It is very simple. Again, like I mentioned, you pick up any IP address in the VPC range. Okay, let's say while creating VPC, you have provided the range as 172.16.0.0. Pick up any IP address. I mean, you said the VPC IP address range should be 172.16.0.0 to 172.16.255.255. That is, you have 65,000 IP addresses. Now pick up any IP address. So let's pick up 172.16.3.4. Let's take this as an example. And as I've told you, represent this in the octet format. That is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And finally, 1, 2, 3, 4, 5, 6, 7, 8. Right? So I am representing this particular IP address. You can pick up any IP address. I am representing this particular IP address in the IPv4 byte standard, where for each byte I have written the bits. So overall, if you combine, here there are 8 bits. Here there are 8 bits. Here there are 8 bits. And here there are 8 bits. So if you combine all of these things, what is the output? 32 bits. Right? And as I have mentioned you, each of this particular thing can represent only between 0 to 255. And I have mentioned I just need 256 IP addresses for the finance domain. So only this last thing is enough, right? So if I just provide 172.16.3.0 to 172.16.3.255, I got my required 256 IP addresses. So I don't need this 8, this 8, this 8. That means this 8 can be common, this 8 can be common, this 8 can be common. Only this thing will vary. So what was my VPC IP address? VPC IP address was 172.16.0.0 to 255.255, right? So all these three things can be common for my device. So this can be the host network or the common things, and this has to vary. So that's why I'm providing 172.16.3.0/24. Why 24? Because I've cancelled 24. That is, all this 24 bits can remain static, can remain same, and only this 8 bits have to vary. So that's why I said 0 followed by 24. Don't worry, I'll try to explain it one more time if you did not understand. So what was my VPC IP address or the primary network address? 172.16.0.0 to 172.16.255.255. This was my IP address range, right? Now, if I just need 256 IP addresses, I can pick up something like 172.16.3.0, 3.1, 3.2, 3.4 to 3.255, right? What are the number of IP addresses here? 256 IP addresses, right? So this solves my problem. Either I can pick 172.16.3.0 to 3.255 or 172.16.4.0 to 4.255, 5.0 to 5.255. Anything solves my problem. So what I can simply do is, if I need 256 IP addresses from this particular VPC range to provide to the finance network thing, either I can use 172.16.3.0/24, 4.0/24, 6.0/24, or even 244.0/24, right? I can provide any of these things as the CIDR range for my subnet. Now, let's make it even more simple. Let's say, right, this is my office network, and here same, I want a finance domain, finance subnet, and this is my free subnet. And in the finance subnet, I just want 2 addresses, nothing more than that. I just want 2 addresses. And here, right, here I want to provide rest all addresses for the devices that are getting connected. So if I just need 2 addresses, what I can simply do is I can provide 172.16.3.0/31. Why 31? So if you remember the hyphens thing, there are 32 hyphens, right? Out of which I have cancelled 31 hyphens. So there is only one hyphen left. And one value of a bit is nothing but it can be either 1 or it can be 0. So there are two IP addresses that are generated. When you are calculating the CIDR thing, right, you should not calculate from 2 power 0. So if you have 32 and out of which 31 are striked out, so there is only one that is left. So always try to calculate 32 minus the number that is provided here. If 31 is provided, 32 minus 31 and 2 power the number that is left. So here 2 power 1 is left. So the answer is 2. So similarly, if we are taking 24 here, 32 minus 24, what is left? 8. What is 2 power 8? 256 IP addresses, right? So if you just want, let's say 32 IP addresses, what you will do? 32 minus 27 is 5 and 2 power 5 is 32. So I can simply provide here 27. So depending on this particular calculation, you will take the CIDR range. So if there is a IP address like this, right? So if there is some IP address like subnet with CIDR range like 10.0.0.0/8. What does that mean? 32 minus 8, which is 24. So the number of IP addresses is 2 power 24, which is almost like, I think, a very huge number, right? 256 into 256 into 256. So that's a very huge number, 2 power 24. So whenever you are seeing something with /8, which is nothing but it is also called as class A IP addresses. And if you are seeing something with /16, which are called as class B. When you see /24, which is called /C, here you just have 256 IP addresses. Here you have 256 into 256. And here you have 256 into 256 into 256. This is just a common representation. Don't worry, most of the times you will see /8, /16 and /24. But along with that, you might see /27, you might see /28, you might see /29 as well. Whenever you are seeing something like this, don't get panicked. Just simple thing that has to come to your mind is 32 minus 27, which is 5. So number of IP addresses is 32. When you see 29, 32 minus 29, which is 3. So number of IP addresses is 2 power 3, which is 8. Very simple calculation and straightforward, right? So this is the thing that has to be in your back of mind. So next time when you create a VPC, observe these things carefully. Or you are on OpenStack, you are on Azure, anywhere, whenever you are creating a new network, okay, it will immediately ask you for the range of that particular network. So let's say when I'm creating VPC, it will initially ask me for a range. And range I can provide, like I told you, either 10, 172, 198, anything. So I'll just say 192.16.0.0/16. That is, I will have 65,000 IP address. And now when I create subnets inside this VPC, depending on the requirement from the development team or depending on the requirement from the team, if they are asking 32 IP addresses only, what I'll simply do, I'll say 192.16.3.3 or 4, anything here, 3.0/27. This is what I'll give you. And why I'm doing it very quickly, because I'm very used to this particular calculation. So you can take few calculations as example. In internet, you just search for CIDR calculators, you will get hundreds of it, and verify if your calculation is right. So tomorrow, if someone is asking me that, Abhishek, this is my VPC and I want to create a new VPC, subnet with 64 IP addresses. I just want subnet with 64 IP addresses. Immediately what I'll do is I'll just, okay, look at this IP address. Randomly, I'll say 192.16, whatever is my favorite number. So I'll just say 5.0/, okay, 64. This is 2 power 6. So 32 minus 28, sorry, 26 is 6. So 2 power 6 is 64. So I'll just say slash 26, right? Now, why I'm only modifying this particular number? Because they are asking below 256. So below 266, I'll just modify this particular thing. This will be static. I'll just put this as 0. If they're asking more than 256, let's say someone is asking me 65,000 IP addresses. So what I'll do, 192.16.0/0/16. This is the CIDR range that I would provide. So I hope these examples made the concept of CIDR clear to you. And what you will do is go to the CIDR calculator on internet and take random numbers like this and try to estimate what will be the CIDR number for it, or what will be the number of IP addresses for it. I can give you some assignments. What is the number of IP addresses for this particular CIDR range? Okay, let me write in a new one. What are the number of IP addresses for this particular CIDR that you see? 172.168.3.0/30. And what is the CIDR for 10.0.0/8? So in the comment section, you can mention what will be the number of IP addresses for both of this CIDR range. Let me see how many of you can get this right. And before we move to the next topic, there is one more thing that you have to remember. Most of the times when we talk about private subnets, you will see these numbers only: 192, 172, 10, right? Why you would see mostly these numbers is because these are the ones that are used for private subnets. Okay, so this is just like a practice. So even with Amazon or wherever you are creating, you would see these numbers as the starting ones when you create private subnets, because these are the numbers that are used for private subnets, right? So when you are creating a private subnet, your CIDR range cannot be 3.4.5.6 or 5.0/24. This cannot be your thing, because probably this public one of these public IP addresses has been taken by some particular website. For example, 8.8.8.8 is a public IP address that is taken by google.com. This is the DNS for the google.com. So if you keep this for your application, there will be a conflict. So anytime private IP addresses should be starting with this only, right? So I hope this concept is clear. So what did we cover till now? Till now, we covered the concept of IP address. We covered the concept of CIDR. We covered the concept of subnet. Within subnet, we try to cover what is private subnet. We try to cover what is public subnet as well. These are the things that we have covered till now. And the next concept is about ports. Ports is again a very, very simple concept. You don't have to get confused with it. So whenever we provide IP addresses to connect to websites, we provide some ports, right? Colon 80, colon 443, or we say colon 3600, or colon 8080. What exactly are these things? So basically, to bind an application. So let's take a virtual machine. Okay. On this virtual machine, I have deployed an application. Okay. Now on this virtual machine, there can be number of applications. Okay. So what you can do is, for application, you can provide a unique port. Again, ports are also in a particular range only. You cannot create port with number 1 lakh, right? So, and there are some ports that are taken also, right? For example, there is a specific port for MySQL. Better not to take that particular port. Or there can be a port for Jenkins. Usually Jenkins starts on 8080. So better not to take that particular port. So whenever you are starting your application, start with unique ports such as 9000, right? Or you can take 9191, these kind of ports, right? For example, better not to take ports like 3306, which are taken by other kind of applications. So these things comes with practice. And what if you go back to the topic that we are discussing, Whenever you create application on a virtual machine, to access this application from the internet, you need two things. One is the IP address of this virtual machine. Of course, if it's a public IP address, only you can access it from the internet. If it's a private IP address, you can access only within your network. Let's say this is a public IP address. So to access this particular application, if this application has port 9191, so you will say 172.16, sorry, public IP address, let's say 3.4.5.8 colon 9191. Now, if this application has port 5162, so you will access using 5162. So what is a port? Port is a unique number for your application. In an instance, there can be hundreds of applications, and using port, you can distinguish the request has to go to which particular application. Let's quickly recap what we have learned as part of episode 1. In episode 1, we learned about IP address, what exactly is a subnet, what are the different types of subnets. We learned about CIDR, how to read, write, and perform calculations on CIDR blocks. If you are not aware of these networking basics, I'll highly recommend you to watch episode 1, and the link to episode 1 is in the description. Now let's move towards the whiteboard and start understanding the concept for today, that is OSI model. We all interact with servers on a day-to-day basis. Let's take a simple example. Let's say I open my laptop, open one of my favorite browsers, and search for google.com. Within a fraction of seconds, I receive a response back, which is nothing but Google homepage, a HTML page, basically. But how does this thing happen? How is my request from my personal laptop sent over the internet to one of these Google servers? And how is the response received back to my personal laptop? What are the different components that are involved? And what are the different layers in which the journey of data takes place? So I'm calling it as journey of data because whatever you are trying to request and whatever you are trying to send is all data. So OSI model is one of the popular models that helps you understand the journey of data across the internet. What are the different layers that are involved? And OSI model explains this entire thing in 7 layers. Layer 7 to layer 1. Sometimes it can be layer 1 to layer 7 if you are at the receiving end of the data. But what exactly each of these layers do? What happens to my data in each of these layers? When I say layer 7, layer 6, layer 5, layer 4, layer 3, 2, and 1, what each of these layers actually do? How my data gets transformed in each of these layers, and finally, how does it reach one of these Google servers? Let's try to understand the same thing in today's video. We will use the same example, that is request to google.com, and let's try to understand the complete workflow here. Before we understand the journey of data, that is, even before your browser initiates a request to the Google server, there are two things that happens. That is, even before the OSI model comes into picture, they are: number one is DNS resolution. It is also good to understand these concepts before you understand the OSI model and what each and every layer does, because this is also part of the entire workflow that you are trying to learn, the networking concepts. DNS resolution, and the second thing that happens is the TCP handshake. Now, why these things happens even before your request is initiated, right? Even before the request starts or even before the request is sent, why these things happens? Because let's say you are searching for, or you are trying to make a request to https www google.com. First of all, what your router, that is your home router or your browser tries to do is they will try to verify if www.google.com is mapped to any particular IP address. So there is a system called DNS, which is nothing but domain naming service. You can understand it as a simple database, right? Just try to understand it as simple database where records are maintained, right? If I have to explain this in a very simple way, just try to understand that every router has this information, which is records of domain name mapping with IP address, right? So when you are saying www.google.com, in this domain naming service, there is an IP address against the google.com domain name. Now, when you search for this www.google.com, router verifies this initially in the local cache, right? Just like your laptop has a local cache or you have the local memory. Similarly, your router initially searches this for in the local cache where previously if your router has made a request to this particular website, it might have maintained its records in the local cache. If this information is not available in the local cache, then it goes to your internet service provider and verifies this particular mapping. If there is any mapping for the domain name in your internet service provider's DNS. Every internet service provider maintains a DNS where the complete records are available, right? So google.com is usually mapped to the IP address 8.8.8.8. So if this mapping happens, if this domain that you're trying to reach is actually valid, only then you will move to the second stage. Why this needs to be performed? Because let's say I'm trying to access something like www.Abhishek.Veeramalla.com. Now, this is something that does not even exist. I did not create this domain. I did not map it to a particular IP address. Now, what's the point of starting with this entire data journey? Sometimes you might be uploading some 10 GB file, or you might be sending a huge amount of data. Now, if the DNS itself is not resolved, what's the point of even starting the data journey, or what's the point of even initiating the request? Why should your browser or router initiate a request, right? So this is the first step that happens, DNS resolution. If the DNS resolution happens, then comes your second stage, which is nothing but TCP handshake. Now, what is the TCP handshake? Again, it's a very simple concept. Let's say this is your laptop and this is the Google server. Now, you are trying to send a request to it. You are ready to send a request, but is the server that you're trying to send is ready to accept your request? What if it denies your request even after sending this entire thing, right? What if you cannot make a handshake with it? Handshake is nothing but you are just trying to say hi and it says, hi, I'm okay to accept your request. So there is a TCP handshake, which is usually called as a three-way handshake that gets performed even before your request initiation or even before your OSI model comes into picture. Now, how does this three-way handshake perform? So when you say www.google.com, what your router or browser, what they try to do is they initially send a hi to the server. Like, let's say this is your laptop and this is your server. So initially, router tries to send a hi. In networking terminology, we call it as sync. And if this server is ready to accept, if it says that, okay, I'm good, then it says hi, which is in the networking terminology, sync acknowledged. And finally, your laptop says acknowledged. So this happens in 3 steps. That's why we call it as a three-way handshake. Now you might ask me, but Abhishek, why can't it be very simple as you say sync and it says sync acknowledged and it's done? So it's a very detailed explanation. Let's not go into it. But if you are interested, there is also something called two-way handshake. And there's also something called four-way handshake. So if you are interested, you can go through these things. You can read about difference between two-way, three-way, and four-way handshake. Three-way is the most popular and which is mostly used. So that's why I'm talking about the three-way handshake. But you can also read about these things. So these are the two you can consider as prerequisites even before your data request initiation takes place. One is DNS resolution. Two is the TCP handshake. Now that you understand both of these concepts, that is, if DNS resolution is done and TCP handshake is also done, then your data initiation or your data request initiation starts. Now let's try to understand that in terms of the OSI model. Now I hope you understood why did I explain this even before the OSI model, because when you are learning networking, it's important to understand the end-to-end part of it. Now to start with OSI model, let's take same example. When you search HTTPS www.google.com and I'm assuming DNS resolution is successful and TCP handshake is successful. So what happens after that is your browser, right? Understand this carefully. Your browser initiates a HTTP or HTTPS request to the server. That is this one, right? So you are searching for google.com in the browser. So your browser is initiating a request now. It did not send the request, but the initial process has started. Now, when the initial process has started, it says use HTTP based request. Why? Because you have asked for it. Let's say you're asking for FTP, then your browser initiates a FTP based request, right? So this particular stage is called as layer 7, which is the initial stage and also called as application layer. In this particular layer, you can pass some headers, right? And you can also provide information for the authentication or whatever is required, but this happens in the layer 7. Then comes like once your browser has initiated the HTTP request, right? If I go back to this particular thing, once the request is initiated, now what should be the next step? If you think about it, the next step should be data encryption, right? Because no one in the entire process, like from your laptop to the server, data goes through multiple routers. I'll talk about it. What are these routers? But basically, data first goes to your home router, then it goes to your internet service provider. From them, it goes to a different router, and finally it goes to the Google server. So if your data is encrypted, then even if someone tries to hack your data, they don't understand what exactly it is. And that's where we use HTTPS, right? So when you use HTTPS, the next step that has to happen after the HTTP request initiation is data encryption, which is also called as data formatting. And this layer in OSI model is called as layer 6, which is also called as presentation layer. Now, all of these layers are virtual just for you to understand. So OSI model is trying to just explain you that, okay, this is the first step that happens. This is the second step that happens. And once HTTP request is made, data is encrypted. What should be the next step? The next step should be your browser should create a session. What exactly this is? Very simple. Let's say today you can go to facebook.com and probably search for facebook.com/Abhishek.Veeramalla. 20 minutes later, take a different tab or probably take a different window as well and search for facebook.com/Raju or John. Your browser will not ask you to authenticate one more time. Initially, when you search for facebook.com/Abhishek.Veeramalla, it will ask you to log in into Facebook. But even after 20 minutes, if you search for /John or /XYZ, facebook.com does not ask you to authenticate because there is a session that is maintained. And this session is very, very important because sometimes, let's take example of your banking transaction. Okay. So initially you log into your bank and probably you try to send someone some amount, or you try to make a transaction. What if your session gets disconnected in 1 minute? You just have 1 minute you complete your transaction, or you make a transaction and you want to make one more transaction, right? Unless you log out, your bank server should not ask you to log in one more time. And that happens only if your browser creates a session. We all use sessions on a day-to-day basis. Whether you are using Instagram, Facebook, or anything, there are sessions that are maintained. So once the HTTP request is initiated, second thing that happens is encryption, which is nothing but data formatting in the presentation layer. And then a session is created with you and the server, so that the server does not ask you to authenticate multiple times. And this particular thing is called as session layer. And one interesting thing about all these three layers, right? Layer 7, layer 6, and layer 5 is that all of these three layers are maintained by your browser, right? So all these three layers happen at your browser level. What does that mean? Let's say you're using Chrome, or you're using Firefox, or you're using any particular browser. Layer 7, layer 6, and layer 5 are taken care by those browsers itself, right? Your browser initiates a request, then your browser, depending upon HTTPS and what kind of certificates that you're providing, it takes care of encryption, and your browser only takes care of session. If you want an example, just go to your browser, go to your browser settings, and try to clear cache as well as cookies, and then try to authenticate with the facebook.com. Let's say you authenticated facebook.com. 2 minutes later, if you delete the cookies and cache, it will ask you to authenticate one more time because you have deleted the session. Session is basically stored in cookies and cache, right? So layer 7, 6, and 5 are taken care by your browser itself. We did not even come to the router part. If this is my laptop and this is my server, laptop is connected to my home router. Till now, whatever I discussed is happening in the browser itself. My request even did not reach this particular browser if I'm talking about only layer 6, 5, and 4. Now, the next thing that happens is once the session is also created to transmit the data, right? If we are taking this example, some cases, the data that you're transmitting can be of 10 GB also, right? Probably you're trying to upload a movie or you're trying to do something. So if you are trying to do data in one at a time, like if 10 GB if you're trying to upload it once, or even simple things such as requesting to google.com, what usually happens is your data is segmented, right? That is, the data that you are trying to send or the data that you are trying to receive is segmented and split into parts. So this particular thing is called as segmentation, and this happens in layer 4. Along with the segmentation, in this particular layer, the protocol is also defined, whether you want to use TCP or UDP, right? So there are only two protocols which are like these are the widely used, TCP as well as UDP. And in layer 4, once all of these things happen, data segmentation takes place, and the particular protocol is also identified in this layer. How is the protocol identified? Mostly these are standardized. Let's say if you're using HTTP, the protocol is TCP. If you're using something like DNS or something else, the protocol is UDP. So these protocols are standardized, and if you are using HTTP, TCP is the protocol that is used to transmit the data from here on. That is, the segments of data that got split are transmitted using the TCP protocol. And this layer is called as transport layer. Now, once the data segmentation is also done, now it's time to send the data. And to send the data, the first thing that happens is the data that's sent is received by your router. And what your router does is router does two particular things. One is to this segmented data. Let's say you want to travel from Delhi to Mumbai. Here you know what is your destination, right? You know that you want to travel from Delhi to Mumbai. And second thing is what is the shortest path? Probably you can travel from Delhi to Mumbai in 20 different ways, but you will only pick up the shortest path. Similarly, even in this example, data from your personal laptop to google.com, that is from India to the US, there will be multiple hops for your data. That is, there are multiple routers that are involved. Probably your home router, then your internet service provider, from your internet service provider to etc., XYZ, and finally it reaches the Google server. So which routers or which hops should your data take to reach the Google server in the fastest way? To understand that, what we will do in the layer 3 is that we will add source IP address as well as destination IP address to each segment, right? And here, once you add the source IP address and the destination IP address, we call this data as packets, right? So packets have a clear information of how to travel, which path to take, and who takes this decision. This decision is taken by your router. And this layer is called as networking layer. Just try to take this example. Delhi to Mumbai, if you have to travel, you need to know what is your source and what is your destination. If you want to send 100 people from Delhi to Mumbai, to each and every person, you will tell them that, okay, this is the path that you have to take. Similarly, in layer 3, your router comes into picture and your router tells each and every packet that, okay, this is the source, this is the destination IP address, and you need to travel through these hops, right? And this layer is called as networking layer. Then comes your layer 2. And in layer 2, like, okay, now your router received the information. But if you understand it carefully, usually these routers are connected to switches, right? Even if you look at your home network, your router is connected to an Ethernet port. And from the Ethernet port, your router is connected to the cables, right? So if you're talking about these Ethernet ports, or if you're talking about these switches, right? Now data has to be sent some or the other time to these Ethernet ports or to these switches, right? So at this point of time, when the data has to be sent to the Ethernet ports, the data has to be transformed from the packets to frames, depending upon the medium that you're using. If you are using router, the data is converted into packets. Then if you are using these switches, the data is converted into frames. And in these frames, along with this IP address that you have provided, MAC information is also added, which is nothing but MAC information tells these switches what are the other components within your network, right? So here MAC components are also added. Now you might be thinking, but why can't I use packets? Because your medium has changed. From router, this request is being sent to switches, and switches only understands how data can be transmitted in the frames. So this layer is called as data link layer. Finally, you have layer 1, that is your data end of the day, or your router switches end of the day are connected to optical cables. And guess what language these optical cables understand? The language these optical cable understands is electronic signals, right? So here your data is transmitted into electronic signals, and using optical cables, data is transmitted very fast, right? And this is how your data is transformed, right? If I have to explain this in one single slide one more time, you have layer 7, layer 6, layer 5, layer 4, 3, 2, and 1. So if you take your personal laptop and this is your Google server, for example. Now, when you initiate a request to www.google.com, so initially what your browser does starts with layer 7. I mean, the process starts with layer 7, where first of all, it defines what is the type of request. So mostly we use HTTP type request. So HTTP or HTTPS. Now, once it identifies that, okay, I have to initiate a HTTP based request, second thing that it does in the layer 6 is encrypt the data. Once the data is also encrypted, the next thing that happens is create a session with the server. Now, once the session is created with the server, because data has to be transmitted within fraction of seconds, segmentation of data is important. And that happens in layer 4. And here, along with the segmentation, the protocol is also identified, depending upon the request that you are making. If it is HTTP, TCP request is most widely used. Once the segmentation is also done, right? Now the data is divided into small parts. After that, data reaches your routers, and within the routers, the path to transmit the data is identified, because in this layer, we add the IP address for each and every segment. And here we call them as packets. Once packets are also created, then the next thing is from the routers, you will move towards the switches. And here data is converted into frames, where you add the MAC address of each and every component that is there, so that, like you add the MAC address so that within the network, this switch can understand what are the other components to transmit the data. And finally, layer 1 is a physical layer where these switches are connected to optical cables, and here the data is converted to electric signals or electronic signals, whatever you would like to call, right? So when you initiated the request from layer 7, layer 6, 5, 4, 3, 2, 1, what happened? From your laptop, it went to your router. From router, it went to switch, and it connected to the cable. Now it goes through multiple hops over the internet, and finally it will reach one of these Google servers, right? From layer 1, which is, let's say this is one of the cables, then it is connected to other routers, other switch, and again cable. And this entire thing happens, and the data is transmitted, and finally it reaches one of these Google servers. Now understand carefully what happens here. When this data received by one of these Google servers, again the OSI model comes into picture, where initially data is received by one of these Google physical servers. So one of these Google physical servers is connected to an optical cable. So L1. From there, it will go to one of the switch ports. Then it identifies which router to use. From there, the data which you have been using as packets, like whether it's a TCP or UDP, right? Let's say we are using the TCP protocol. So here the TCP data is taken into place. From there, once you have the TCP data here, then session is validated. After that, de-encryption takes place. From there, it will go to one of the Google's applications. And this Google application will say, hey, okay, this is your request. So let me give you a HTML page as a response back. Here, this application is a microservice or any particular monolithic application which has the source code, and it understands, depending upon your request, okay, I want to generate a HTML page. Now, again, this HTML page is sent back to your personal laptop, and same thing happens, right? Before it reaches your personal laptop, your router is connected to a physical cable. So it has to move from L1, L2, L3, L4, 5, 6, and finally reach your particular laptop. So this is the entire OSI model. And, basically, when you are sending the request, L7 to L1 data is transmitted, right? Data is transmitted through L7 to L1 layers. Now, when you are at the receiving end, data is received from layer 1 to layer 7. So these are not the physical layers, right? These are just a way of explanation of OSI model. For you to understand the data transmission in a better way, OSI model explains it in this particular way. Of course, OSI model is not the latest model. There are models like TCP IP model, right? Which is again based on OSI model. But the thing is, in TCP IP model, L7, L6, L5 is combined because, more or less, these are performed by the same component, that is your browser. So L7, L6, and L5 are combined and called as a single layer in the TCP IP model. So why people usually prefer OSI model? Because this is a standard. And if you understand this standard, you typically understand the entire transmission of data. Whether it's TCP IP model or any new model, they are all based on the OSI model, right? So don't get confused. If you see TCP IP model, it's exactly the same. Only difference is L7, L6, and L5 are combined, and usually they are called as one single layer in the TCP IP model, right? So this is the video for today, and how this OSI model is helpful for the DevOps engineers. I will tell you that it is not completely must have thing, right? This knowledge is kind of a good to have thing. I'll tell you the reason why. Because these days all of these things is standardized, and this entire thing is completely automated. Like you won't see anyone using Wireshark these days unless you are working in the core networking company, and probably if you are dealing with the layer 3, layer 2, or if you are involved in any sort of networking companies, only then you see people using these kind of things, right? The Wireshark or any tools to decrypt the packets, understand this thing. But if you have a high level knowledge of OSI model, that is more than enough. You don't have to dig dive and try to understand what are the different protocols in layer 3, right? You don't have to understand what are the different types of techniques that are available in layer 2, because this is an ocean, and whatever I taught in this particular video, it's more than enough if you are trying to understand networking as a DevOps engineer. So today's class, let's learn what is virtual private cloud. Let's understand why you need virtual private cloud, what are the different components of virtual private cloud, and also how do they interact with each other. And finally, there is a fear amongst a lot of people that virtual private cloud is a difficult topic. You might say that, yes, Abhishek, we have that concern because VPC involves a lot of networking. There are multiple components, and it's difficult to understand why and how each of these component is interacting, what purpose are they solving. So don't worry if you have any such fear, or even if you are completely new to networking and VPC. After today's video, you along with me will say that virtual private cloud is an easy concept, and I understand this concept end to end. So we will do practicals as well, but practical will not be part of today's video because it is very, very important to have strong foundational knowledge on VPC. So today's video, I will try to add that foundational knowledge on VPC for you. And in tomorrow's video, we will deep dive into slightly more complicated topic of VPC that is related to security. And in day after video, we will try to do a practical video, deploy application inside VPC and explore the complete flow of VPC. So that will be the entire thing. But how will I make this concept easy for you? You might ask me. What I'll do is I will take a real life scenario. Okay, so we will take a very much real life scenario that all of us understand, and we will use the same real life scenario to understand the concept of VPC. So this real life scenario has nothing to do with AWS, but still I will correlate and make this concept very, very easy for you in the lines of AWS. So let's quickly start the video and understand virtual private cloud. So to start with the example, the scenario that I was talking about, let's say that there is a huge land. Okay, so let's call this as a village. Okay, so we have a village and there are a lot of people in this village, but there are specific set of lazy people in this village. Okay, so these lazy people are lazy enough that they can't construct their own houses. Why they can't construct their own houses? Because they don't want to maintain their houses, they don't want to manage their houses, and also they don't want to go through all the construction process and everything related to their houses. So these people, they are actually looking for some people, and at the same time there is one wise person in this village. Okay, let's say that this wise person is called ABC. So there is a wise person called ABC in the village. What he has done is he saw this opportunity of lazy people and he said that, okay, let me grab this opportunity and make money out of it. So this wise person ABC, what he has done is he went to this village and he acquired a huge land in this village. Okay, so he acquired this entire land in this village and he said that, okay, hey lazy people, what I'm going to do is I'm going to construct the houses for you, but for that you have to send me a request with your entire requirements, like what are the resources that you require in this house, what is the capacity that you require in this house, and fill me all the details and give it to me. And in return, I'll give you house and I'll take money from you, right? So this person has started the process, and what this ABC or the vice person has done is he has constructed this house in the land that he has acquired. So he purchased this entire land and he constructed a house, and he said that I'll maintain this house for you. So this person felt happy for it, and then seeing this other person also approached, and he has constructed house for the other person as well. So in future there is one more person and he has constructed house for that one more person. So it is going well, and all of these people, their problem is solved, that they don't want to maintain the entire construction and maintenance. This person, the vice person ABC, is taking care of it, and they are all happy. But there are other bunch of people. What they have done is they saw this, they were happy about it, but they realized that these bunch of people, they have realized that there is some kind of security issue here, there is some kind of privacy breach. That means for the purpose of saving a lot of money, what this person has done is he has constructed the houses, but they are very nearby, and there is some kind of security breach that anyone who access this house can hack or access the other house, and can also access the other house. So that way there is some kind of security breach that is happening here. So these people said that, okay, we are also looking for houses from you, but we want it in a much better way, not in this way where if one of these houses is compromised, that the other houses are also compromised. So this person, to not to lose the business, and because he want to construct more and more these things, what he said is, okay, give me some time, and he came back with a new concept called secure land. Okay, so what he said is, okay, I have this entire property, but if you come as a group, where if you want a group housing or something, what I can do is I can build a secure property for you people. So inside this entire land, what this person ABC has done is he has built a secure property for these people. And this secure property, what he said is only people who have access to this secure property. Like he said that I'll construct a gate here, which will act as a gateway, right? So this gate will act as a gateway, and only these people or the people's relatives or people who know these people only can enter this secure property, right? So what happens is, let's say someone wants to meet this person, okay, and this person has one property here, the other person, this person has one property here, and this person has a property here, right? So now there is one of the relatives of this person, right? Let's call this person as A. Now the relative of A wants to meet this person. So what the secure property does is, this person can definitely meet him, but he first has to pass through this gate. So there can be a security guard or someone who will guard this property, and once he enters this, so this is a property that all of these people own, right? So this secure property, this is all the public thing where everybody owns this. But if this person, this XYZ person, let's say he wants to go and meet this person called A, now he need to understand how to go to this property, right? Now because I'm drawing this picture, you know how to go from here to here, but eventually to go from here to here, there has to be another guide here. So this guide basically explains, okay, move from here to here, and finally you'll reach the person A. Again, once you reach this person A, there will be another security guard, or there will be some kind of person here who will validate, okay, is this the right person? You entered the gateway, you moved into the secure property, but again, do you want to meet A? Do you want to meet B? Do you want to meet C? So if you are a valid person who wants to meet A, then only I will accept your request to meet the person A. So this way, what this ABC, the vice person, has done is he has solved the problem of security breach and solved the problem of security. And now everybody is enjoying the secure property. Looking at these people, there are another bunch of people who came to him, and he has built another secure property, another secure property, another secure property. This way he started making his business. Now, why did I explain this story to you people? You might be thinking, has Abhishek gone mad? Why is he saying all of these things? And how is it going to be related to AWS? Okay, now let's try to relate the same thing to AWS. In the last class, I showed you how to create an EC2 instance, how to deploy an application, and how to access that application, right? So now let's go to the same scenario where there is this big region. Okay, so let's call this region as Mumbai or Ohio or whatever you would like to. What happened was there are people, okay, so there are companies, let's say this company as example.com, this company as example1.com, then there is another company called example2.com. So these people, initially they were maintaining their own data centers, but it was becoming too hectic for them. So they said that, okay, if there is someone who is going to help us with this data center, we'll offboard that to them. Or there is a new startup. Now they said that, okay, we can't afford to build a new data center, we can't afford to maintain it. Now we are also looking for someone. So AWS saw this opportunity, right? So in this case, who is the vice person? AWS is the vice person. What AWS said is, hey, okay, what I can do is inside this region, let's say there is a region called Mumbai or Ohio or throughout the world, what AWS did is AWS started building their own data centers. In the previous example, that person has acquired a lot of land, right? The vice person. Here, what AWS did is AWS started purchasing or building their own data center. So AWS built this entire data center in Mumbai region, for example, or Ohio region, or Frankfurt. Anywhere, AWS started building their own data centers. Now what AWS said is, hey lazy companies, or hey startup, hey example one, example two, example three. So we can host your applications inside our data centers, or you can request us saying that, hey, I want one virtual machine, I want 10 virtual machines, I want 20 virtual machines, and we will take your request. You give me money and I will create the instances for you. So this was going by I mean this exact same thing what we did previously, and this was going very fine, where example.com one, they requested, and what AWS did. So this is the story of 2013 2014. Okay, so during this time, what AWS did is, if example.com is requesting it 10 EC2 instances, so it went to the data center in region Mumbai or whichever region it requested, and it created 10 EC2 instances. Okay, so again, inside the data centers, there will be multiple physical servers. Let's say this is a physical server, and example.com requested 2 EC2 instances, so it gave 2 EC2 instances inside this server. Let's call it server 1. So then there is example 2. And what AWS did is it created again request of example 2 in the server 1 only. Then there is example 3, and what AWS did is again it went to here and it created server. Let's say it requested for one server, it created in server 1 only. Here what I'm talking about, virtual machine 1, two virtual machines and two virtual machines. So this is fine. All of this problem is solved, and AWS is also giving them virtual machines inside the data center. Inside data center, like I told you, there can be multiple servers. For one server, AWS choose one server and solved all of their problem. But what happened is, let's say, so this is a theory. What can happen is that in this case, so if there is a hacker, and let's say this is startup, okay, let's say this is startup. If there is a hacker here, because they were not maintaining proper security, he entered into this server. He tried to make some false request to this application inside the physical virtual machine, and he was able to hack this particular server. Now, because all of them are in the same physical server inside the AWS data center, hacker can easily come here. Hacker can easily come here. Hacker can easily come here, and he can hack the entire thing, right? So just because of example 3 or just because of startup, what happened is all of the servers are hacked, because AWS was creating entire instances, or AWS was creating all the things in same things, or it can also create in different things. But what happens if it creates in the same server? Right? So till 2013, 2014, this was happening. So to solve this problem, like I told you, even in the previous example, to solve the security breach, what AWS said is, okay, we will come up with a new concept. In that case, it was secure community. In AWS terms, it is called as VPC, right? So what AWS said is, we will build a VPC for you. Or in the other way around, like in the previous case, the builder will build the entire secure community and give it to you. But in the AWS terms, AWS will give you documentation. AWS will give you examples. Who is the one who builds this entire VPC and maintains the VPC? It is DevOps or AWS DevOps engineers. Okay, so AWS DevOps engineer, looking at the documentation of AWS, they will go to the AWS portal and they will request for the VPC, and they will configure everything inside the VPC. Now let's see what is inside the VPC using the same example itself. In the same example, what I told you, I'll try to convert that into AWS example, right? So this is AWS data center. Again, so there is, let's take example of one company here. So let's say there is TCS, and inside TCS, there is one project, and this project is owned by a DevOps engineer. So what this DevOps engineer does is he will go to AWS, and let's say there is a region called Mumbai. He'll go to AWS and say, hey AWS, give me a VPC. Now, how do you define the size of a VPC? In the previous case, because it was a land, you can define the size of land in some acres or in some hectares or something. But how do you define the size of a VPC? So for defining the size of VPC, there is something called as IP address range. Okay, so what is this IP address range? So IP address range, whenever a DevOps engineer creates a VPC, what AWS asks is, what is the IP address range? So if you say, for example, the IP address range is 172.16.0.0/16, that means AWS will allocate 255 into 255. Now don't worry about this calculation, what is Abhishek calculating and what is happening here. You will understand this in future. For now, understand that AWS will give you 65536 IP addresses. Okay, so how do you define the size of a VPC? You can define the size of VPC using the IP address ranges. So DevOps engineer will say, hey, for our project in TCS, I need this particular IP address range for the VPC, which means I need 65536 IP addresses. So technically you can assign this IP addresses to 65536 applications, instances, whatever you would like to call to, right? So this much IP addresses can be allocated using the VPC. But what DevOps engineer will do is, TCS can be one project, but inside the project, there will be multiple sub projects, right? So there can be one project related to payments, one project related to transactions, one project related to XYZ. So what this DevOps engineer will do is, for one internal project, let's say there is one internal project here, there is one internal project here, one internal project here. So this DevOps engineer will split the IP address ranges, right? So what he will say is, okay, for this particular sub project, this particular sub project and this particular sub projects, divide the IP addresses. So here he will say 172.16.1.0/24, 2.0/24, 3.0/24. So this particular thing will get some 255 IP addresses, this particular thing will get some 255, and this particular will get some 255. Okay, now again, don't worry about the calculation, how Abhishek is calculating and all. That is irrelevant to this discussion. For now, just understand that for TCS, there will be internal projects, and depending upon the internal projects, this DevOps engineer will split, saying that, okay, even the VPC might have one IP address range, but I will split them to 3 different IP address ranges for 3 projects. And this particular concept is called subnet. Okay, the name itself says that it is subnetwork, right? So it is subnet. What you are doing here, the VPC is created with a particular IP address range. You are splitting the IP address for your sub projects. DevOps engineer is splitting this for the sub projects, calling it subnet. And inside this sub project, let's say this sub project has only one application. So you deploy an EC2 instance and you deploy that application. Here there can be 2 instances. Here can be 3 instances. Depending upon the sub project, it is up to the sub project development leads how many applications do they want to deploy inside a subnet. They will contact a DevOps engineer as well. But for now, let's say this is the configuration. So there is sub project, sub project, sub project, 1 application, 2 applications, 3 applications. So now what DevOps engineer will do after this, once he creates the subnet and all, now DevOps engineer, like we discussed in the previous example, he will create a gateway, right? Why is this gateway required? If there is no gateway, nobody can access this particular VPC. Right? So without a gate, nobody can enter the gated community or the secure community. Similarly, without this gate, nobody can access or enter to this entire property itself. Let's say there is a relative in previous case here. Let's say there is a customer who wants to access application in this EC2 instance. There is customer who wants to access application in this EC2 instance. So he has to definitely come through this gateway itself to the VPC. So firstly, there will be a gateway. And what this gateway will do is, gateway is just like a pass for someone to enter to this VPC. Now, once they enter, what will happen? Like I told you, this is one subnet, this is one subnet, and this is one subnet. But this is all a free space, right? Inside the VPC, these are the subnets which we call as private subnets because they don't have access to internet. But then there is something called as public subnet, right? So what is public subnet? Public subnet is the one that a user first access inside the VPC. So how does public subnet connect to the user, or how does public subnet connect to the internet? Basically is using the internet gateway. So this particular thing, this particular gateway here, we call it as internal gateway. Sorry, internet gateway. Through the internet gateway, there is a public subnet from which the user enters to this. Okay. Once the user enters, basically there, let's say there is a load balancer here. Okay, what is load balancer? Load balancer is the one that forwards the request depending upon the load. For example, there is this application and the user from the internet want to access this application. Now how will the request from this public subnet from the load balancer goes to this application, right? So there has to be a particular path. So for this public subnet, what you will do is you will create something called as a router. In AWS terminology, you will call it as a route table. So you will create a route table. This route table defines how should application or how should the request go to the application, right? So you have a load balancer. Load balancer can send the request depending upon the target group. We will discuss about load balancer in detail later, but for now just understand that there is an internet gateway. Once from the internet gateway, there is a public subnet. From the public subnet, request goes to the load balancer. Load balancer is assigned with the public subnet. And for the load balancer, what you will do is you will create a target group of this application. Okay. So now what happens is if the request from the load balancer has to go to the subnet, load balancer does not know how to go to this particular thing. So what you will do is for this subnet, you will create something called as a route table. Okay. So this route table defines and tells the load balancer, okay, go through this particular path so that you will reach me. And once the request from internet now reached here, but still at the EC2 instance, like I told you in the previous example, there can be a security guard here who can block your request. Similarly, for the EC2 instance, there can be something called as security group. Okay, so there will be something called as security group, where this security group can say, okay, so on which port do you want to access me? Or from which IP address are you coming from? What is your IP address? Then the security group can say, okay, only if it is coming from this particular IP address in the internet, only if you are trying to access me on a particular IP address, then I will allow the access, and that way you will finally reach your application. Okay, so what is happening on the whole? If someone from the internet is trying to access an application in the private subnet here, first of all, the request has to go through the internet gateway. Once it reaches the internet gateway, it will go to the public subnet in the VPC, right? What is public subnet? It's a common subnet across the VPC. Once it goes to the public subnet, there is a load balancer here, right? What is load balancer doing? Load balancer is attached with the public subnet, and load balancer has a target group. So when request goes to the load balancer is the one that takes the request to the private subnet and to the application, right? So to reach, I mean, for the load balancer to understand how to go to this application, the subnet is here, but what is the route path for the subnet? So there is something called as route table, right? So route table is the one which defines the path. Once the path is defined, it can go here, but still there is something that can block, that is called as a security group. Once the security group also allows you, your request is finally reached. Now let's try to write these things, okay? So that you understand what exactly has happened. First of all, from the internet, right? So let's say this is internet. There is person in the internet here. He is using a laptop. And what he is trying to do is he is trying to, let's say, access an application, which is called, for example, example.com. Or okay, let's leave the a domain and let's call he is trying to reach something called 172.16.3.1 slash something. Okay. In general, he'll not use the private IP address. He will use the load balancer IP address to reach there. But for your understanding, let's say he's trying to reach one application in the private subnet. Okay. So to reach, what I have told you first is there is a DevOps engineer who has created a VPC, right? Inside the VPC, what is there here? There is basically an internet gateway. Okay. So let's say this is the internet gateway. And then inside this VPC, right? If you call this entire thing as VPC, which has a basic IP address block or the IP address range. This entire thing has a IP address range. Inside this, what he has done is for project A, he has created a subnet. Project B has created a subnet, and project C he has created a subnet. Again, what is a subnet? This is the entire IP address range. So for each project, you can divide the IP address range. If this IP address range is 172.16.0.0/16, this can be 172.16.1.0/24, 2.0/24, 3.0/24. That way you can split. Now let's say there is one application inside this subnet, one EC2 instance, and end goal is to reach from here, from the internet, which is completely outside of VPC. You want to reach from here to here. Okay, so what is the process? Firstly, it will come here. It will see that there is an internet gateway here. It will pass through the internet gateway. And once you pass through the internet gateway, like I told you, there is a public subnet here. Okay, what is public subnet? Public subnet is the one that can be accessed to the public outside the VPC. But they have to pass through the internet gateway. Once they pass through the internet gateway, in the public subnet, there is something called as load balancer. In AWS world, you will call it as elastic load balancer. Okay, so you have elastic load balancer. It can be application load balancer, network load balancer. We'll talk about that later. Now you have an elastic load balancer here. So what this elastic load balancer does is your request from the external world has reached the elastic load balancer. From the elastic load balancer, now it has to go here. But how will the load balancer understand that it has to go here? This is a private subnet, right? But for elastic load balancer or for the load balancer to send your request to the private subnet, there has to be a proper route. Okay, so who will define this route? There is, like I told you, something called as a route table. Okay, now you need to have a route table, and using this particular path, your request has to flow, right? So what you will do is for elastic load balancer, one thing, you will attach the private subnet and you will attach the target group. Okay, so what is target group? You will understand when you learn more about the elastic load balancer. But for the load balancer to understand request has to go here. Firstly, you need to create something called as target group, and you have to assign this instance to the target group. And at the same time, the subnet should have the route table so that the traffic is flowing here. Okay, so and here, like I told you, there is a security group which can block the request or accept the request. So these are the entire flow. What are the components that we talked till now? One is internet gateway. Then we talked about public subnet. Then we talked about load balancer. Then we talked about route tables, which are basically routers in other terminology. So routers are the one which forwards a request. Even from your home laptop, if you're trying to access a particular website, there are routers and there are multiple hops. Using multiple hops, different routers connect to each other and forward your request. And finally, your request goes to a particular server. Even in AWS, that's the same, but you call it as route table here. So you have route table that you understood. Then you understood about security groups. Right, so these are the critical components of VPC. Additionally, there are few things which I'll cover very quickly, but in future class, that is in tomorrow's class, we will talk about them in detail. One is like, let's say you have one security group here, you have another security group here, you have another security group here. Okay, but within a subnet, okay, if you want to define the same security group to multiple applications, multiple EC2 instances, or you want to repeat the security group configuration, there is something called as NACLs. Okay, NACLs are basically automation for your security groups, where instead of defining the same thing again and again, you can define that as part of NACLs. Okay, and finally, there is one more concept that I will explain and I'll conclude today's class. That is the concept of NAT gateways. Now, what is NAT gateway? I'll try to explain in this scenario itself instead of directly explaining you the example and see the concept of NAT gateway. Now the request from here has reached this application, which is well and good. But now what if the request, now what if this particular application here tries to access something from the internet? Okay, now till now we talked about this workflow, right? Workflow flowing from here to here. But what if the application tries to access something from the internet, from google.com? Let's say this application wants to download a package. which is quite common, right? You might want to download something to your server. So there is a server here and you want to download something from internet. So what is the problem here? You might say that, okay, again, it can use the public subnet and it can flow and it can access it. The only problem is that, okay, the request can flow. How the request will flow is a different challenge. We will discuss that. But the only thing is, when someone tries to access some resource from the internet, one of the critical things that you have to remember is, if this is in the private subnet, that means that there is some sort of security here. So it is a bad practice to expose your applications or to expose your server's IP address to the internet. Okay, so whoever is receiving this in the internet, so let's say you are trying to download something from xyz.com. Okay, so xyz.com should not know the IP address of your server, or it should not know the IP address of your application, anything. It should not know it should not know the IP address of your private subnets applications or the servers, EC2 instances. It is going to be both theory and practical. And theoretically, practically, we will understand one of the most important concepts of VPC, which adds additional security, that is security groups as well as NACL, right? So this is what we are going to learn in detail today, both theoretically and practically. So please watch the video till the end, so that even you can perform this activity, like even you can take this as an assessment and you can try this at your end by watching this entire video. Got it? So now, without wasting any time, let's quickly see what is this security group, what is this NACL, and what exactly they are going to do within the VPC. So if we go back to yesterday's video very quickly, what I told you is, if you consider this as VPC, right? Let's say this is a virtual private cloud. And I have explained that, okay, in the world of virtual private cloud, the very first thing what you will do, this is a real life example, right? How organizations use VPC as of today, this is the same thing. So initially you will have something called as an internet gateway, right? So usually what happens is, within the VPC, there will be a public subnet. So, and there will be private subnet, right? So what is a subnet? Basically, I explained in the last class, when you create VPC, you will define what should be the IP range, or what should be the IP address range of your VPC. It is just, in the similar terms, you can consider how many IP addresses you want inside this VPC, right? So usually, let's say that when I create a VPC, if I say that the IP range has to be 10.1.0.0-16, then that technically means you will have within the VPC 65536 IP addresses. Okay, so this defines the size of VPC, how big a VPC or how small a VPC. So when you have 65536 VPC IP addresses, that means technically you can use 65536 applications components within this VPC. Okay, so let's not go into the detail of this, but just understand that when you create VPC, then you define an IP address range which defines what should be the size of your VPC. Now within that, you can divide subnets. So subnets are basically like, within VPC, if you have multiple projects. Okay, so as a DevOps engineer, you have created an AWS account, then you have created a VPC for one of the project. Within the project also, there will be internal projects, right? So for each internal project, for group of applications, you can define private subnets. Okay, so these private subnets basically will not have access to internet. That's why they are called private subnets. So by default, these applications cannot be accessed from internet. So that's where VPC comes into picture. And what VPC does is, whenever, let's say this is a user. Okay, I know that I'm taking time here, but this is very, very important for everyone to understand. When user eventually want to reach here, like, user want to access an application here, what happens is, user firstly tries to go through this internet gateway. Okay, and this is a public subnet where anyone can access this public subnet. Okay, saying that you can add few conditions here through the internet gateway, and through the API gateways, you can add conditions and validate few things. Is this user good user, bad user, hacker, or whatever it is? We will talk about that later. So through the internet gateway, initially what happens is, within this public subnet, DevOps engineers usually place a load balancer. Okay, so load balancer can be directly accessed from outside world. And what happens is, this load balancer will talk to this private subnet. Okay, so load balancer is the one that has access to private subnet, and this user has the access to load balancer. And within the load balancer also, you can do a lot of configurations. You can restrict traffic, you can say that, okay, etc, etc, and you can make this more secure with the load balancer as well. But today's topic is about once the load balancer forwards the request to the private subnet. Okay, so there are two things. One is you can add additional security at the layer of the subnet. Okay, for each subnet, AWS says that, hey, you can add more security at the subnet level. Okay, so if you add more security at the subnets level, what we will do is we will start using NACLs. Whereas even if you bypass this, let's say you have not added anything at the subnet level, you can, as a DevOps engineer or the application owner, what you can do is you can add more security at the EC2 instance level. Okay, the level where your application is actually deployed. So at the EC2 instance level, if you add security, then we call it as security groups. So using security groups, you can add more security at the EC2 instance level. Whereas if you want to add more security here at the subnet level, then we will use NACLs. Okay, don't worry, even if you haven't understood exactly what is happening here, when I deep dive and explain it further, you will understand. But for now, here what I wanted to explain is, in AWS, there are multiple layers where you can add security, because security is one of the key components. For any organization, if they want to move to public cloud, what they will first see is that public cloud secure enough or not? You can talk about costing, you can talk about any level of things, but for any public cloud, tomorrow if there is new public cloud, what you will first see is how secure this public cloud is, because you are going to put all of your application in the public cloud, right? So if your organization is using AWS, it will have your organizational user details, you will have details like the database, and everything is hosted on AWS. So first thing organizations look at is how secure is AWS, and that's where AWS says that, okay, we will do our part. So the fundamental thing that AWS says is, in AWS, security is a shared responsibility. Understand this sentence very keen. In AWS, security is always a shared responsibility. What does this mean? So AWS says that, okay, from our side, we will try to add as much security as possible. Like, we will tell you that you can use VPC. We will tell you that, hey, you can add security groups, you can add NACLs, you can add API gateway, you can add a lot of security. But along with that, we will need, that means AWS is saying, along with the things that we are adding, we need help of DevOps engineers or AWS admins, whoever it is, like, right? Most of the times, AWS admins are also DevOps engineers these days, or network admins, system admins, whatever your company calls it. But AWS says that security should be a shared responsibility. We will do our part. As DevOps engineers, AWS admins, or network admins, you also have to do your part. And that's exactly where all of these component comes into picture. Whether adding load balancer for your organization, do you want to use default load balancer, different load balancer? Do you want to use API gateway or not? And how exactly you want to configure security groups and NACLs? All of these things, DevOps engineer plays a very critical role. In today's topic, we will debug and deep dive into security groups and NACLs, which comes at the last point of security, right? Which comes at the last point of security. But this is very critical, because if you are not taking necessary actions at the last point, then your application will be easily hacked, right? NACLs and security groups are very critical because of this very reason, that is, they act as a last point of security in your AWS account, just before the user request reach the application, right? If this is user and this is where the application is, it has to travel a long path, right? The request has to travel a long path within the VPC. It goes through multiple components, but when it reach here, before this point, the last point of security is served by security groups and NACLs. Okay, so that's why this is very important, and we will try to focus. I will explain you like what and when to use security group, and what and when to use NACLs. So firstly, let's start with this concept on understanding what is the primary difference between security groups and NACLs. So security group basically serves at the instance level. Okay. Now, what do I mean by this? On day 3, so whoever has followed our day 3's video, or in general, what we have done on day 3 is, firstly, we created an AWS account, right? In the AWS account, in the default VPC, like whenever you create AWS account itself, AWS will give you a default VPC. Without VPC, AWS will not deal with anything. If you want to create custom VPCs, you can do, as we will do today, but by default, AWS will give you a VPC. And what we have noticed is, we created an EC2 instance, and within this EC2 instance, we tried to deploy a Jenkins application. And as a user, we tried to access this Jenkins application. What happened? We were not able to access this application by default because, as I showed you in that video, there was something that was blocking this one, right? So by default, as I told you, in AWS, security is a shared responsibility. And by default, what AWS says is, we will not allow anything to your instance directly. Okay. So if you want to do that, you need to configure your security group. Okay. So if we want to configure anything at the instance level, that we do within the security group concept in AWS. And that's exactly where, to access the Jenkins application deployed in the EC2 instance, we have allowed port 8080, or you can also allow all traffic. Okay, so this is where DevOps engineers and the application owners have to be very careful. Instead of opening port 8080, let's say in your organization, you have opened some other port. Let's say you have opened port 9000, 10,000 and multiple other ports. And there was one hacker who was trying to access this, and they were luckily able to access these ports, and they tried to hack something. Okay. Or additionally, whenever you open ports that are not used, or you keep opening a lot of ports, then there can be some kind of unwanted traffic that can flow to your EC2 instance and reach the application. So AWS is doing the part of by default not accepting any traffic. Whereas as DevOps engineer, you have to do your part by allowing only specified traffic into your EC2 instance and into your application. That thing is done by security groups concept in AWS. I hope this is clear. If you still feel that this is not clear, when we do the practical, you will understand. We will deploy a Python application and I'll show you this same thing again using the security groups. Now you might ask me, okay, this is a very easy topic. So it is an easy topic, but there are few things to understand in the security group. So within the security group, basically, there are two things. One is, there is inbound traffic and there is outbound traffic. What is inbound and what is outbound? Basically, when you deploy your application inside the EC2 instance, right? So if this is an EC2 instance and this is your application, there are two kinds of activities, right? What is the first activity? As a user will try to access your application, and as an application, probably you will try to access google.com, or you will try to access something to get some kind of information, or you want to access some third-party application. So this traffic that is flowing into your application, okay, this is called as inbound traffic. And this traffic which is flowing outside of your application is called as an outbound traffic. For example, let's say this application that we are talking about is Amazon.com. This is just a blunt example. Okay. So user, today I can be a user who will try to access Amazon.com, and Amazon.com probably can access any third-party application, for example, Razorpay. Or Amazon.com can access other application like Amazon Pay. To access Amazon Pay, Amazon.com, this request has to move out of this one, right? Go out of your EC2 instance and access some other application, that is Amazon Pay, and user will try to access the application. So this access where user is trying to access Amazon.com is called as inbound traffic, whereas Amazon.com trying to access the Razorpay or the Amazon Pay is called as a outbound traffic. Okay, so as part of security groups, you can manage both inbound traffic and you can manage the outbound traffic. That is traffic coming into your EC2 instance and traffic going out of your EC2 instance. Again, like I told you, you should be very careful, because AWS by default, what it does, okay, by default, when you create a security group, or by default, when you create an EC2 instance, AWS will assign a default security group, because AWS will also take care of your security, right? So in this default security group, what AWS says is, hey, what I'll do is by default, I will allow all the outbound traffic. Okay. All the outbound traffic I will allow. Like using your application, you can access anything in the internet except for port 25. I will tell you why. There is a story behind this port 25, but except for port 25, I'll allow you all the outbound traffic. And what AWS says is, but anything that is coming inside, okay, anyone who is trying to access your application as inbound traffic, I will deny everything by default. Okay. In the security groups, what AWS is doing is for the inbound traffic and for the outbound traffic. Okay. For the inbound traffic, what AWS is saying is, okay, I have a lot of restrictions here. I don't want to allow anything. If you want to allow anything, then you can use the concept of security group inbound traffic rules, and you can add the specific port number or the specific IP address where the traffic has to be accepted. But as part of outbound traffic, I'll allow everything. And if you want to restrict, okay, or if you want to do any specific configuration, you can do in the outbound traffic. Okay, so this is the thing related to inbound and outbound traffic. We will see in the practical video how we can use this inbound traffic, outbound traffic. Now talking about the story of port 25. So what happens with port 25 is that, so in this story, AWS does not allow the outbound traffic default on the port 25 because port 25 is basically a mailing service. Okay, so AWS does not want you to, AWS does not want any kind of spam activity, or AWS does not want to record the IP address of this EC2 instance or record the IP address where your application is hosted. So AWS by default blocks the port 25 only outbound traffic. There can be a lot of spamming activities or something like that. Okay, so now let us see if security group is doing all of these things. Now, why I need NACL? First of all, what is NACL? Right? You might have this question, Abhishek, you have been talking about NACL. You keep saying NACL, NACL. What exactly is this NACL? So NACL basically stands for Network Access Control List. Okay. So this is a very complicated name. That's why in the world of AWS, people just call it as NACL. Okay. So NACL, Network Access Control List, basically goes a level beyond. Okay, so security groups is applied at the EC2 instance level, whereas NACL is applied at the subnet level. Okay, NACL is applied at the subnet level. Now with NACL, DevOps engineers can play even critical role, because let's say you gave an EC2 instance for development team 1. And what this development team did is, just to make their process quicker, what they have done is they have deployed a Jenkins application or any other application. They know that they should not allow all the traffic, but to make it easy, what they have done is they just said that, okay, allow all the traffic inside my EC2 instance. Instead, they could have just opened port 8080. But what they have done is they said, okay, accept everything. Allow all the traffic to my EC2 instance and allow from all the IP address in the world. It can be IP address from Turkey, it can be IP address from India, allow everywhere, everything, and I'm fine with it. So the problem is that this particular instance owner or this particular development group, they have, for some reason, they have ignored the security aspect in the AWS, right? Because security groups are meant to open only specific ports and allow only specific traffic into the EC2 instance. So how and what you can do as DevOps engineers is, instead of, okay, so this is fine. Every instance owner, they can open specific ports, whatever the traffic they would like to. But additionally, what AWS says is, if you go back to the previous diagram where I said, this is VPC, and if this is public subnet, this is private subnet, right? Similarly, there will be a lot of private subnets. So what AWS said is, we will give you more access. Instead of instance owner defining what kind of ports or what kind of traffic is allowed, if they do some kind of mistake there, and if they say that allow all kind of traffic, as DevOps engineers or administrators, you will have one more layer where at the subnet level, at each of the subnet level, what you can do is you can define what kind of traffic do you want to deny. Understand this carefully. Here I am saying what kind of traffic do you want to deny. So if you deny some traffic at the subnet layer, even if you try to do that, or even if you try to accept that at the security group layer, there will not be any advantage. So DevOps engineer, network engineers, or AWS administrators, what they can do is they can make advantage of NACLs to define their organizational network traffic. Okay, so if something is applied at the subnet level, then it is by default applied to all the instances within the subnet. Okay, so if there are 50 EC2 instances, sorry, if there are 50 EC2 instances inside this private subnet, let's say you gave this private subnet to development team 3. This is just an example. You gave them to development team 3, and what they have done is they have created 50 EC2 instances inside this private subnet, and for some reason they said allow all traffic. But because you have applied NACL configuration and you said by default deny all the traffic and allow only specific things, if you say that at the NACL layer, what will happen is AWS will deny all the traffic that is flowing in and only allow the configuration that is defined in the NACL. So NACL will add as an additional layer of security. Got it? So instead of applying the configuration for each and every EC2 instance, also you can use NACL for automation. So maybe in your organization, DevOps engineers are the one who is taking care of the instance level security, that is security groups, as well as NACLs. Then what you can do effectively is, instead of adding security groups for each and every EC2 instance, if you just apply NACL to the subnet, if there are 10,000 EC2 instances also, this NACL configuration is directly applied to all the 10,000 EC2 instances. Okay, so that you can automate this manual activity of assigning the rules to each and every instance using security group. So it is up to you whether you want to use security group, whether you want to use NACL, or you want to use the combination of security group plus NACL. Okay, so NACL, basically the primary purpose is you can deny what kind of traffic that you would want to, and you can allow what kind of traffic you want to, whereas security groups is only for allowing. Security group does not have deny thing. In security group, you will only configure the rules for allowing. So now we discussed so much here. Probably for some people there might be some kind of confusion. So what we will do is we will try to deal this same thing practically and make it understandable for people. Practical part that I am going to demonstrate on the AWS account today. So if you watch this carefully, what I'm going to do today is, this dotted lines represents virtual private cloud. So firstly, I'll create a custom virtual private cloud. You haven't seen how to create virtual private cloud, so that's going to be interesting. So firstly, I'll show you how to create this virtual private cloud on AWS. And when you create virtual private cloud, as I told you, security is a shared responsibility. So as I create virtual private cloud and provide the IP address range, AWS by default will create an internet gateway for me. AWS by default will create NACL with default configuration, and AWS will create a route table. Additionally, what I'll do is I will create an EC2 instance and attach a security group to this EC2 instance. Now, once we do this, we will play with this security group configuration and NACL, and we will see how traffic flows into this EC2 application. Sorry, application inside the EC2 instance. What happens if I block something in the security group? What happens if I allow something in NACL and block that thing in, allow something in security group and block that in NACL? Right? Allow, block, allow. We will try a lot of things. So let's see how does this configuration go. And you can also try the same thing as your assignment. So because I'll share you all the steps right now, you can watch the video and you can follow the steps as I do. So let's quickly go on to the AWS management console here. So this is the AWS management console, right? So what I'll do now is move to the service called VPC. So this is the VPC service. Some people might be watching this for the first time. They might have not seen VPC before. So what we will do here is, once you go here, you have a lot of things within the VPC. Don't get scared. Some of these things you have already learned about in the previous classes. What is VPC? What is subnets, route tables, internet gateway, security groups. Today we learned about NACLs as well. If there are few things that you don't understand, don't be scared. Eventually you will understand all of those things. So click on VPC and let's click on create VPC. Okay, so there is two options here. I mean, there are two options here: VPC only, VPC and more. Go for VPC and more because AWS will take care of creating the resources for you. I mean, the default resources for you. For example, when I create this VPC using VPC and more, what AWS is going to do, AWS is going to create public subnet for me as well as private subnet for me in both the availability zones. Right? I am in the region North Virginia. In North Virginia, there are two availability zones: US East 1A, US East 1B. So AWS will create four subnets, the public subnet and private subnet for me, so that I don't have to create a lot of configuration. In real-time example, like I told you, public private subnet combination is used more. Then AWS is also going to create route tables for me. Finally, it creates internet gateway. IGW stands for internet gateway, and it also creates some VPC endpoints for S3 bucket, which I'll tell you later. Right now, S3 buckets is not taught in this series, so don't worry. Perfect. Now, what I'll do after this is you can provide any name or you can use the random name. So I can provide some name here for this VPC. Let me call this name as demo VPC. Okay. And this is exactly what I've been talking about. So here, if you see, if I provide this configuration /16, what AWS is saying me that you will get 65,536 IPs. If I want to modify, if I just say this as 1.0/24, see what happened. AWS said that you will get only 256 IP address. So in future, if you require more than 256 IP address, then you have to modify this VPC or you have to add additional configuration. So whenever you create the VPC, if you have an understanding of what is this going to be, what is the size, then that's better. And you can modify these things as well. For example, instead of 10.0.0. Something, you can also change this to 192 series or whatever series that you would like to. So let me just change this to whatever AWS was giving me by default. And now what I'll do is here you can configure number of availability zones that you want. Technically, I want only one availability zone because this is just a demo thing, but let it be. You can go with the defaults at this point of time because you are just learning. Number of public subnets. I want public subnet because if you go back to the diagram, I am going to do this entire thing using public subnet only. Perfect. All the configuration is provided. Now I can simply, like this VPC endpoint, right now you can put it as none as well. But if you want to go with default, let it be as S3 gateway. Click on create VPC. Now the VPC configuration will be created. See what exactly VPC is doing. Firstly, it created the VPC. Then it is configuring the DNS. We will learn about DNS tomorrow. Don't worry. Then VPC creation is done. It has created subnet for me. These are combinations of public and private subnet. Then it created internet gateway. That's why I keep saying security is the shared responsibility. AWS will create configurations for you. Additionally, you have to look at those configurations. You have to modify those configurations if required, add additional security if required. AWS has then created route tables, create route, associate the route tables with the public private subnets. And finally, AWS has also done the route table creation. Okay, so this is all the things that are created as part of this VPC workflow. Now let me go back to the VPC that is created for me. And here you can also look at the rough diagram of how does this VPC look like. Just go to the resource map and here you will get a total picture of how your newly created VPC is looking like. So just spend some time here and try to understand what is happening here. This is exactly what I've taught you on day 4. So you can understand. If you don't understand, you can ask me any specific question as well. Perfect. Now this part is done. I've created the VPC. AWS has created internet gateway for me. See, this is the default internet gateway. In this picture, you can see if you scroll down. So this is the default ingress gateway that AWS has created for me. And AWS also creates NACL and security groups, which you will see. So let me go back and create the EC2 instance now, because I want to place the EC2 instance in the public subnet of the VPC and demonstrate security groups as well as NACL. Go to instances, click on launch instance. What we will do different in today's class from the previous class where we created EC2 instance is, let me call this as demo instance. Let me choose the flavor as Ubuntu. T2 micro is fine for this class, no problem. Provide the key value pair, whatever you would like to use. I'll use this one called AWS login, for example. Here in the network configuration, you have to edit this, right? So edit the network configuration, and in the network configuration, don't go with the default VPC. Default VPC is the one AWS creates for you so that you can start working with it. If someone does not know the concept of VPC, they just entered or they just started with AWS, they can use this default VPC and they can play with it. That's what we did on class 3. On the day 3, we use the default VPC, which comes up with all the default configurations of AWS. But now I want to play with my custom VPC. In your organizations, you will always use the custom VPC only. So demo VPC, let me click on this one and see what subnet is getting allocated to your instance, right? In this case, AWS is saying that I will allocate the private subnet for you, which is a general industry practice. By default, your EC2 instance and the application should be in the private subnet. But because today we are trying to understand this concept and not going in detail load balancer and all the other configurations, so I will change this to the public subnet. How do I do that? Just go back here and change the subnet demo subnet public 1 US East 1. Okay, so because I'm in the availability zone, I want to play with only one availability zone. I've choose the US East 1 availability zone. Assign public IP address. Yes, I need a public IP address for my EC2 instance. Create security group or select any existing security group. Like I told you, if you are not aware of these concepts, then you can ask AWS, to select any existing security groups. But in this tutorial, I'm going to play with the AWS use custom VPC. So let AWS create security group for me and then let me tweak it. Rest all the configuration looks okay to me. Let me create on launch instance. Now what we will do is inside this AWS EC2 instance that is getting created for me, I will install a Python application. Okay, I will just use a very simple Python application on this EC2 instance. And what I'll do inside this Python application is I'll run the application on port 8000. And now I'll try to access by default. I think most of you already know that when you try to do this, the security group will block because the default security group that AWS created for you will not allow the traffic directly. You need to allow the traffic explicitly. So I will enable all traffic. I will enable port 8000 and show you what happens. And then we will try to block the traffic. We will say block all traffic in NACL and see what is going to happen. Okay, so this is going to be interesting. Now the EC2 instance is also running. Let's get the IP address of the EC2 instance and log into the EC2 instance using my terminal. So this is my terminal. What I'll do is SSH. I hope I have that PEM key. AWS login PEM. Perfect. Change the IP address also. Great. So let's see. Log into the EC2 instance. And what is the first thing that you do after login to the EC2 instance? You need to update the packages, right? Because I want to run the Python application. So firstly, I want to update the packages. See Python is installed. And then I will run a simple HTTP server. So firstly, do sudo apt update. It will not take much time. All the packages are getting updated. It will not take much time here. Perfect. All the packages are updated now. Now let me see if Python is installed or not. So let me just run Python 3 command. Perfect. Python is also installed. Now I will just run a very simple HTTP server on Python. For that, you don't even have to write a single command, or you don't even have to write a single file. Just say Python 3 -m http.server and provide the port, whatever you would like to. So a simple HTTP server is now running on port 8000. Ideally, if you open this instance on this IP address and access the port 8000, you should be able to access, but let's see what would happen. So we saw the same thing in the last class as well on day 3. There I've used Jenkins and I tried to access the IP address on port 8000, which failed, and then I enabled, right? So let's try to do the same thing now. This is my instance. Copy the IP address. Just say HTTP colon IP address colon port 8000. The application will not be accessed because what is happening? Let's go and see. This is the EC2 instance. This EC2 instance is attached with a security group. This is the default security group that is attached. And what is happening in this default security group is that, what AWS is saying is I will allow only port 22. This is the port 22 that is only allowed. The reason is also because AWS AWS only wants to allow the SSH traffic. If this is also not allowed, then we will not be able to even log into the EC2 instance. So only SSH is allowed. And let us see what is the NACL configuration as well, right? So if we look at the NACL configuration, just go I'll take a different tab here and open VPC, network ACLs. So what is the network ACL attached to our VPC? This is our VPC, right? Demo VPC. So let's go to that specific thing and see what are the inbound rules. Why are we looking at inbound rules? Because inbound rules is the one that is coming to our application. So it says all the traffic is currently allowed. So network ACL, which is the first layer of defense, which is the first layer of defense for the entire subnet. What is configured here? It said that, okay, allow all the traffic. I don't have any problem. You can say that there is also deny rule here, but deny rule will only be triggered if this condition is not met. Okay, so order goes with the order of priority. Whatever is here in the first row, so it depends upon the number. So least number will be here first. Let's say I'll configure one more rule and the rule number is 200. So first rule 100 will be verified. Then rule 200 will be verified. And finally it will go to rule star. Okay, star is the last thing. Here this condition is met, right? If this condition meets, that is if all the traffic is allowed, then there is no problem. Okay, let's say here instead of all traffic, I can also say only allow custom TCP traffic of port 8000. Or I can say allow only custom TCP traffic of port 9000, which we will see. But for now, all traffic is enabled. So no problem from NACL. What AWS did here is from the internet gateway, you got entry into the subnet. Okay, because NACL is allowing all the traffic. So internet gateway can forward the request to the route table. If there is a load balancer here, then the request would have gone to the load balancer. From the route table, request goes to the load balancer. But because there is no load balancer here, from internet gateway, if NACL accepts, then the traffic goes to the route table, right? So let me add an arrow here so that it is much clear. So this is what has happened here. From the NACL, now traffic goes directly to the route table, and route table would forward the request to the EC2 instance. Let's see what is happening and why. If NACL is accepting, why the request is not going to the EC2 instance? That is because security group is blocking it. First layer of defense is cleared, but the second layer or the last layer of the defense, which is security group, is blocking the request. Now let's try to unblock it. So for that, go to the security group, edit the inbound configuration, add one more rule, and inside this say allow port 8000. So custom TCP means the custom port 8000 of TCP. You are allowing port 8000 from any IP address. For now, you can say any IP address anywhere in the world. The resource that is using IPv4 anywhere in the world. Just save the rules. And as soon as it is saved, you will see that the configuration will be applied to EC2 instance. And if I just refresh this page, you will see the output. What is this output? Basically, I'm just running a simple HTTP server, right? I'm not running anything more than that. This is a very simple HTTP server. So that's why what is happening here is the request that you have sent is listing out the directories that are available in that folder. Anyways, you got the request output. You can verify or validate this request output here as well. So you got 200 response. That means the request is successfully sent and you have got the response back. Now, what if, okay, what if you have opened this port, right? So where is this? In the security inbound rules, you have opened this port. Let's say you are the instance owner, you are not the DevOps engineer. And as part of the instance ownership, what you have done is you have enabled port 8000, but your organization has a very strict rule that the port 8000 should not be enabled. So as DevOps engineer, you can configure this, you can control this thing at the NACL level itself. Because you cannot monitor each and every EC2 instance and you cannot control every EC2 instance, you can say that for my organization or for this particular VPC, I will block port 8000 in the NACL, right? Or the network ACL configuration. See then what would happen. So the power of DevOps engineer using NACLs. This is security group. Where is NACL? Let's go to the NACL. Yep. This is NACL. This is the inbound rule. What I will do is edit inbound rules. Instead of allowing all traffic, just remove this, add new rule. And what you will say is in this specific rule, let me call this rule as 100, custom TCP, port range 8000, I want to block. Anything that is coming from internet, just deny. Now let's save this change. Okay. And let's try to copy this URL, take in a different browser and just try to enter it and see. Now you will see that the request will not reach the application. That is because DevOps engineering team has blocked that specific IP range, or DevOps engineer has denied that particular traffic in the NACL. So it will be blocked for the entire subnet. Whether you are EC2 instance owner, whether you can be anything, because the network configuration is blocked, you cannot access. Now again, let's try to edit this inbound traffic rule and say that for 100, I will just say all traffic allow, save changes, edit inbound rule. I will add one more inbound rule. Okay. And that inbound rule number is 200. Okay. Custom TCP, port 8000. Any guesses on what would happen? I will deny this. Let's see how much you have understood here. I have added this rule number as 200 and I have denied the traffic. Let's see if I save changes and refresh this, you will see that the traffic is sent. Even you have denied the configuration in the NACL, because NACL goes in this specific order, right? So the order would be, first you will verify AWS will verify the first lowest number. The lowest number is 100, or it goes with the specific order that is mentioned here. It is mentioned in the ascending order itself. So firstly, it will check rule number 100, which says all traffic is allowed. So this rule is met. AWS will forward the request. The request goes to security group. In the security group also, you have allowed that port 8000. So it directly reaches the specific application. What happens if I simply rename this one? Like if I make this as 200 and if I make this as 100, save changes. Now, okay, so let's save one by one. So let's keep this as 200. Let's keep this as 110. Okay, you can keep any number. It just has to be the order. That's it. Now try to save the changes. So it will reflect, and 110 goes above now. So this is the first rule. What it says is if the port number is 8000, block. If the port number is not 8000, then it will go to the next rule. What does the next rule say? Allow all the traffic. Now let us see what would happen. Just copy this URL, take this in a different tab and try to refresh. Again, the traffic will not reach the EC2 instance. The thing is, now the application developer will be confused. Hey, what happened? I have allowed the port 8000 here, but still my application is not getting the traffic because DevOps engineer or the network engineers have blocked this specific port. Now this port, they might have blocked because there might be some security reasons, there might be some concerns. It's not just about the port, but with the NACLs, you can play around with different things. You can play around with the IP addresses. Let's say you are worried about some IP address that is coming from XYZ country. And you know the IP address range, you can say block the IP address that is coming from 3.4.5.6 range. Or if you know the specific IP address, you can provide the specific IP address. If you know this, if you don't know the specific IP address, you can provide the range as well. 3.4.0.0/16, right? You can say anything. You can block on the IP address. You can block on the port range. You can play around with NACL and security group configuration. So what you have understood at the end, even if you allow the configuration in the security groups, NACL acts as the first layer of defense, and DevOps engineers as well as system engineers, network configurations, or the admins who has access to NACLs, they can overall block the configuration at the subnet level, right? So today we understood the topic of NACL and security groups with respect to allowing the access and blocking the access. Please take this as an assessment. You can watch this practical part one more time and you can try this at your end. This is really, really important. Today we just tried with one public subnet. In future, we will enhance the scope. We will add the private subnets. We will add load balancers. We will add API gateways. We'll add a lot of configuration, multiple availability zones. So this concept you will understand even more in detailed way when we play with other components of AWS. But for that, today you have to practice this and let me know in the comment section. Were you able to try the assessment? Were you able to solve this? Do you have any questions? Please let me know in the comment section and I'll more than happy to reply to it. So firstly, let me give you a brief overview and what is this project about? What are we going to implement? What are some things that we need to understand before the implementation of the project? Firstly, this project demonstrates how to create VPC and how to secure your applications within a VPC in a production environment, right? So if you look at the architecture diagram here, there is a VPC and inside the private subnet, we have deployed the applications. And there is a public subnet where you have load balancer and the NAT gateway. Users would access this application through the internet gateway to the load balancer, and from the load balancer, it will reach the applications in the private subnet, right? So this is the entire architecture that even I am trying to explain here. So you can pause the video here and you can also just read through this entire thing so that you can explain this same thing when interviewers ask you in the interview process. But just an overview, like in 4 lines, first we will create a VPC that has public subnets as well as private subnets in 2 availability zones. Now, why I need 2 availability zones? You can ask me like, Abhishek, when you explain the theory part, you were just using one VPC. In that VPC, you are only using one public subnet and one private subnet, and that too in one single availability zone. But when you do this in production, just you need to create 2 availability zones instead of one, so that for some reason, if the data center of AWS in a specific region or the availability zone of AWS in a specific region goes down, you will still have the other availability zone that is serving the traffic for you. So that's the only purpose. We create a VPC with public subnet and private subnet in 2 availability zones. And in the public subnet, what we will do is we'll deploy a NAT gateway and a load balancer. Why you need load balancer? I'll explain you. But why you need a NAT gateway? Let's say this applications here, if they want to access something from the internet, probably they want to get some JSON information, or they want to get some kind of information from other APIs in the internet. So it is better to mask the IP address of these applications when they send a request. So that's exactly what NAT gateway does. So let's say the IP address of this one is 172.16.1.0 or 172.16.3.4. When the application or when the EC2 instance tries to access something from internet, what this NAT gateway says is, okay, let me change your IP address to the public IP address of mine and send the request so that your information will be hidden. Even if that third-party application is a false application, or even if it is hacked, there will not be any problem because you don't know, I mean, that person does not know the IP address of this server. That is about the public subnet, and in the private subnet you will launch these applications using an auto scaling group. Okay, what is auto scaling group? I'll just explain you in a minute. Finally, we will see how to reach this application through the internet, how traffic flows, and we will also, I'll also tell you how these applications access internet using the NAT gateway. So this is going to be the complete overview. And before I jump onto the video, you should know about these 4 things, because I covered these things in the day 0 to day 6, but I did not cover them to an extent that it is registered for everyone. Bastion is something that I did not cover at all, but the other 3 things I covered, but not to the fullest. So let me give you an overview. Auto scaling group, load balancer, they have dedicated sessions in this AWS Zero to Hero series. But in this project, I'll use them so that you should understand the summary of it. Firstly, what is an auto scaling group? So auto scaling group is, you can just understand it as a concept. Let's say you want to deploy your application in 2 availability zones. Instead of creating your EC2 instance 2 times, what you can do is you can just tell the auto scaling group that, okay, so create minimum of 2 replicas. And in case my application receives more requests, and if 2 servers are not enough to load this 2 servers, 2 servers are not enough to accept the traffic, incoming traffic. Let's say 2 servers can only accept 100 requests, but there are 200 requests that are coming at you. What auto scaling group can do is it immediately can take a decision and scale your servers to 4 in number, 5 in number, 6 in number, right? So this is a very basic example of auto scaling group. In future, we will discuss about auto scaling group in detail, so don't worry about it for now. Then you have load balancer. What is load balancer? The name itself says what is load balancer. It is something that balances the load. Let's say there are 100 requests. Now we have 2 servers, right? There is server 1 here and there is server 2 here hosting the same application. So load balancer takes the responsibility of sending 50 requests here and 50 requests here. Or if you have this instance very powerful, right? So you can say send 60 requests here, 40 requests here, 80 here, 20 here, and load balancer will exactly balance the load, right? Apart from that, using load balancer, you can also do path-based routing, host-based routing, different kinds of routing mechanisms, which we'll cover in depth when we come to the load balancer topic in the AWS Zero to Hero series. And one final topic is what is Bastion or a jump server. This is a very, very simple concept. So these EC2 instances, right, that we are creating are created in a private subnet. So they don't have a public IP address, or we cannot SSH into these instances directly. So what we will do is, because we want to keep them secure, we will not create any IP addresses, public IP address for them, but we will create a Bastion host or just a jump host in this public subnet. And through that Bastion or jump host, we will connect to this EC2 instance. And there are multiple advantages of using Bastion host. The one mechanism is the same thing that I've just told you. If you use Bastion host, instead of directly connecting to this server, you can connect from the Bastion, so that there will be a proper logging mechanism. You can do proper auditing of who is accessing this private subnet. You can configure bunch of rules in that Bastion host where the traffic actually moves, or the SSH traffic actually goes to this application in the private subnet through the Bastion host, right? So we will discuss about advantages of Bastion host again, because this is not the topic where we want to discuss about Bastion, but this is a topic where we want to implement this entire architecture, right? So I think we have enough information. Now we can get started with the project, and let's see how to implement this end to end on an AWS account. Okay, so I have logged into my AWS console, and let's start with the creation of VPC. So go to the search bar, type VPC. So you will see an option for isolated cloud resources VPC. Click on that. So you will find an option called create VPC. Click on create VPC, and there will be 2 options here. One is to create VPC only or create VPC and more. If you click on VPC only, then you have to create all the things by yourself. Like for example, you need to create all the subnet configuration, IPv4, IPv6, and a lot of other configuration. But the better thing is to go with VPC and more. So when you click on VPC and more, you will see in the preview diagram what AWS creates for you. So AWS creates a public private subnet in US East 1A availability zone, and it will also create a public subnet and private subnet in US East 1B as well. So if we go back to our diagram, which we have been talking about, right? So as I told you, you can search that in the AWS Black blocks as well. Just search for AWS public private subnet architecture. So this is the blog that I was talking about, which I wanted to share in the description. This blog also has the information, but you don't have the complete details in this blog. Like they are very high level. Probably, someone might not be able to follow this and execute this. So I'll explain in much better way. So just use this diagram as reference, and we can implement that in our own style, the style that we have learned from day 0 to day 6. So see what we are trying to do here. When you click on VPC and more, what AWS is creating, one public subnet in US East 1A, one public subnet in US East 1B, which is what we want, right? One public subnet here, one public subnet here. And then you have one private subnet here in US East 1A and one private subnet in 1B. Exactly same, one private subnet here and one private subnet here. So VPC is getting created, subnets are getting created, and what all? So along with the subnets, of course, the subnets have to be attached with the route table. When I explained the VPC architecture, I told you route table is the one which defines how to route the traffic within the subnet. So if the subnet is not attached to route table, technically nothing happens with the subnet. So if you look at the public subnet, it is attached with a route table that has a destination as internet gateway. Awesome. That is exactly what we want. This public subnet should have a route table with internet gateway attached to it so that traffic flows into the public subnet. So that is also done by the VPC here. Great. And finally, you have two private subnets which have two different route tables expected because these two route tables are different, and it is attached to a VPC endpoint for S3 bucket. Now I don't want this one because this project has nothing to do with VPC endpoint. And when we talk about S3 buckets, you will understand about what exactly this is. For now, just ignore this, and I'll also remove this from the configuration. So okay, VPC and more is what I want. Then select the name of the project. Let me call this as AWS prod example. Use the same subnet. There is no problem here because in this VPC you have 65536 IPs, which is too much. So that's totally fine. I don't want to touch it. No IPv6. I don't want to play with IPv6. I'm just using IPv4 configuration. Number of availability zones. It is 2 that I require. Perfect. Number of public subnets 2. If I change this one, the reference diagram also gets changed. Number of private subnets 2. NAT gateways, yes. I want one NAT gateway in one particular availability zone. So let's say one per availability zone. And this is the VPC endpoint that I'm talking about. Just click on none. You will notice that this diagram also changed. And now there is no VPC endpoint for S3 bucket. Perfect. Now let's click on create VPC here. And see that AWS creates bunch of resources for you. So take a pause here and read what all the resources that are getting created, because this is very, very important. Okay, maximum number of addresses have been reached, the elastic IP addresses. That's not a problem. Let me go back and see how do you delete that? You can just go to the EC2 console. This is again something useful information. While you do demos, this is the advantage. So there is an issue here while I was creating the VPC. So the number of public elastic IP addresses is reached. So let me go here and release some elastic IP addresses. Okay. So these are some previous projects that I was doing. So let me release those IP addresses. If the IP address is released, then AWS will allocate this elastic IP address to the other things that I am using. So now if I go to the VPC console, let me click on retry here. So you will see at this point of time, the elastic IP addresses will also be created. What is elastic IP address? Elastic IP address in AWS is nothing but an IP address that will remain the same even if the instance is deleted. Let's say you terminate an EC2 instance. I'm just giving an example. If you assign EC2 instance with an elastic IP address, what will happen? Even if the EC2 instance goes down and comes back, the IP address will remain the same. In general, it does not remain the same. But if you're using elastic IP address, then the IP address will remain same. in very simple language, if I have to explain in a plain English, elastic IP address can be called as a static IP address because it never changes. Okay. So in this case, the elastic IP address, in my example, it will get attached to the NAT gateway because, like I explained you, what is NAT gateway? It will mask the IP address of my EC2 instance or the applications with the public IP address of the NAT gateway. So this is where the VPC is using the elastic IP address. Perfect. Let's see the VPC creation. So VPC creation takes a little time at this stage, creation of NAT gateway to activate. For the NAT gateway to activate, it will take couple of minutes. So you need to wait patiently here for the NAT gateways to be activated. So now all of this is created, but even then you need to wait for a couple of minutes sometimes. Okay. So sometimes your VPC is created, but sometimes AWS takes 1 or 2 minutes to reflect this in the VPCs tab. So if in case when you are performing the demo, when you click on these VPCs and you see that the VPC is not visible here or it is taking time, please be patient. Sometimes it takes time. Okay, now the VPC is created. Let's go to the VPC and see if the resource architecture that we have created till now. Okay, till now, whatever we have created is available or not. Okay, till now, what we have created, we created a VPC with public subnets, private subnets, public subnets attached to the route table and the internet gateway. And the private subnet is attached to different route tables. Perfect. Everything is looking fine till now. Now, what are the other things needed? So the other things that are needed is the EC2 instances where your applications are deployed. We will do them with auto scaling group as I've mentioned, and the load balancer is also missing. Now, once these things are deployed, we will try the traffic from outside, but there is a thing that you need to do additionally. We'll get there. So please watch it carefully. Okay. Now let's go to the console again and create the auto scaling group. So search for EC2. In the EC2, you can go for auto scaling option. Just scroll down. You will see this option called auto scaling groups. Click on create auto scaling group. Auto scaling group in AWS cannot be created directly. You can use launch template. So why you need launch template? Because you can use this launch template across multiple auto scaling groups, or this template acts as a reference. Like tomorrow, if you want to understand how your auto scaling group is behaving, is your auto scaling group scaling 1 instance, 10 instances, 100 instances, you can use this launch template as reference. So let me click on this launch template. Firstly, create that. Launch template will not have much configuration. You just have to mention what is the name of this launch template. Let me just call this name as the name of the launch template as AWS prod example. Let me give the same. And what will be the name? What are you trying to do here? Basically, deploying, okay, verification or proof of concept for AWS private subnet for app deploy in AWS private subnet. Perfect. Now it is asking what should be the operating system of your, or the, what should be the AMI, not operating system. What should be the AMI? Which image do you want to use? Ubuntu, CentOS. Let me just pick up what I've been using. That is the Ubuntu configuration. Click on the recently launched, and this is the Ubuntu configuration. If you want to browse more, you can click here. What should be your instance type? Always pick the free instances when you are doing this proof of concepts. Whenever it is required to use an additional configuration, I'll let you know. In the key value pair, pick up the key value pair that you want to use. Do not touch anything with respect to this specific option here, the subnet configuration. Let it be create a new subnet. Sorry, create a new security group. Okay, and provide the name of the security group. Again, let me give the same thing, AWS prod example. Just say allow SSH action. This is just a description. You can give anything. And here comes the important thing. In which VPC do you want to launch? I want to launch this auto scaling group, the instances in the VPC that I just created. And here you can add any inbound security group rules for the EC2 instances that are getting created. So my application that I'm going to deploy, I know that it is going to be deployed and accessed using port 8000. But what you can do is you can just open all of the things as well if you're not sure about your application configuration. But it is always suggested to keep the port that you are deploying, I mean that your application requires. So what you can also do, like I'm saying, is just open all traffic. But if you open all traffic, then you are not following the security standards. So what I'll do is I'll open the ports that I require. One is the SSH port, that is port 22, that is the port 22, from which source, anywhere. SSH port I want to access from anywhere. So you know this is one. And now add another security group for the application that is deployed inside these instances. So I'm going to deploy a Python application, very simple one. So I will open port 8000. So custom TCP port range 8000. In your case, you can change this according to the application that you want to deploy. And again, let me put accessible from anywhere. And I don't want to add any EBS volumes or any other configuration. So let me click on launch template. You must be feeling, Abhishek, this is exactly similar to EC2 instance configuration. Yes, it will be exactly same, because here you are using the auto scaling group to scale EC2 instances, right? So once you create that, just refresh the page so that auto scaling group will find the launch template. Auto scaling group name, again, let me say AWS example prod, or AWS prod example. What is the launch template? AWS prod example is the launch template. And now let me click on the next button. Here you need to choose the VPC. Okay, which VPC do you want to choose? You want to choose the VPC that you have created with, right? What is it saying? For more applications, you can use multiple availability zones. Okay, but in my case, I want to choose the VPC that I've just created. Availability zones and subnets, in which you want this EC2 instances to be available. Where these EC2 instances should be there? If you go to the diagram, they should be there in the private subnet. So let's put them in the private subnet. This is the private subnet, right? Private one. And this is the private subnet in US East B. So I'm choosing two private subnets. Perfect. Now all the things are available. Let me click on next. Do you want to attach a load balancer now, or do you want to attach a load balancer later? So I'll not attach any load balancer here. Let's just not go with any load balancer. I'll attach load balancer in a different context. I'll just create this load balancer. Okay, so I'll create an application load balancer in the public subnet, but in the auto scaling group configuration for this project, I'm not creating any load balancer. So okay, health checks, everything is good. Let's click on the next button. Desired capacity. Specify the size of auto scaling group by changing the desired capacity. Okay, so let's say you want two EC2 instances. Select this as 2. What is the minimum and how much it can go up to maximum? What is maximum? Like you are saying to start with two EC2 instances, but let's say during Christmas or during Diwali or some other festival occasions, if you receive a lot of traffic, then auto scaling group, when the traffic goes to 80%, 90%, depending upon the CPU monitoring, what you can do with auto scaling is you can tell auto scaling to automatically go up to maximum capacity of 3 instances and 4 instances. So you don't have to worry about this right now. You will learn this when we go to the in-depth topic analysis of auto scaling groups. So you can configure the scaling options here. That's what I was talking about. Like when do you want to define when the EC2 instances have to scale up and scale down. So for now, just keep it none and click on the next button. Add notifications. You can add notifications through SNS topics when an EC2 instance is added or terminated. For now, I don't want any of those things. So let me click on next button and launch configuration. Perfect. Now my auto scaling group is also getting created. Again, this will take 1 minute. So just wait here before you move to the next. So after a minute, you will see that the desired capacity is 2 and the instances are 2. Now let's go to the AWS EC2 and see if this auto scaling group indeed has created 2 instances for us or not. And I'll also verify if one of the instance is created in US East 1A and the other instance is created in US East 1B or not. Okay, for that, let me go to EC2 here. Perfect. and click on the instances. Yes, there are 2 instances. Perfect. Click on one of the instance. Where is this created? See, this is created in US East 1A. Now let's click on the other instance. Go back here. Click on the other instance and see where is it created. See, this is created in US East 1B. Perfect. So you have this configuration also done. So auto scaling group is created, instance is created here and here. Now, before going to create the application load balancer, you have to do one thing, that is install the application inside this servers, right? I want to install applications inside this server. So now what I'll do for that is just go to those instances. So here comes one thing that you have to watch carefully, and this is very important. So let's go to the instance and try log into this instance. So you will notice that this instance does not have a public IP address, and that is expected, right? So I have not given any public IP address here because these instances have to be secure. Now you might ask me, but Abhishek, how do I log in into this? So that's where our Bastion or the Jump host comes to the picture. So as I explained in the theory part, what does a Bastion or Jump host does? So it acts as a mediator between your private subnet, and it acts as a mediator like between your private subnet and the external persons or the public subnet. So I'll create a Bastion host here and access the private subnet from there. Okay. So what we will do is go back to the EC2 console, click on the instances and start creating a Bastion host. Launch instance. So this is, I think all of us already know, just call it as Bastion host and choose Ubuntu as the image. You can choose anything. Then choose T2 micro, provide key pair, AWS login. And what you will do here is make sure you add a security group which has access to SSH, right? So because you need to SSH to the EC2 instance, that is the Bastion host, and from there you have to SSH to this private subnets and install the application. So perfect, SSH is added. Sorry, where is it? Yeah, so SSH is already there, so I don't have any problem. Now there is one specific thing here called network settings. Edit and make sure this Bastion host is created in the same VPC. Okay, so if that is not in the same VPC, then it will not be able to access inside the VPC. So I changed that configuration and added it to the VPC. Perfect. Auto assign public IP address. Yes, enable. Without public IP address, it will not be of no use. Now just go and launch this instance. Okay. I will launch the instance, and once the instance is launched, what I'll do, I'll SSH to this particular instance. From there, I'll SSH to the private host. Okay, so what I'm doing for my personal laptop, I'll SSH to Bastion. From Bastion, I'll SSH to the private subnet. But to SSH to the private subnet, again, you want the key value pair which is present on my laptop. So what I'll do firstly, I'll show you. Okay, so I'll copy my key value pair to the Bastion host as well. Why? Because if the Bastion host does not have the key value pair, let's say Bastion host is here, it does not have the key value pair. How can it log into the private host? Key value pair is in my personal instance. So I will use a shell command called scp. Don't worry, I'll show you all of these things practically. So let me refresh the instances. Now you will see 3 instances. This is Bastion host, and these are instances in the private subnet. Perfect. So let me get my terminal. This is my terminal. And what I'll do is, I know my SSH key is here. I've used an SSH key called AWS. So just search for grep AWS log. I think I've used this PEM file. So firstly, I want to copy the PEM file. Definitely I will log into this Bastion host, but along with login to this Bastion host, I also need to log into these instances. For that, this Bastion host should have the SSH access for these instances, right? It should have the PEM file. So firstly, let's copy the PEM file. So open this instance, get the public IP address of this instance. Okay, now I'll use this command. I'll also try to paste this command in the description so that you can use. This is called as a SCP command, secure copy. So what I am securely copying, I am copying this specific thing called AWS login PEM, which is the PEM file for my private subnet instances as well, from my personal laptop to where am I copying it? I am copying, I'm copying it to the Ubuntu EC2 instance. Okay, so here I'm using the identity file, and then I want to copy this file to the instance. Okay, which instance is this? This should be my Bastion host instance. So let me change the IP address of it. It is very clear, right? What does SCP do? SCP securely copies file from one host machine to the different host machine. Now, from where I'm trying to copy? I'm trying to copy from my personal laptop to AWS EC2 instance, that is the Bastion host. So let's remove this IP address and copy the IP address of the Bastion host. So you will see what will happen. Let me just copy, say yes, and you will notice that the PEM file is copied to the Bastion host. Perfect. It is copied. Now let's go to the Bastion host and see if it is copied or not. How do I log into the Bastion host? Just copy this IP address again. Say SSH -i, your key value pair PEM file location, Ubuntu @ this IP address. Just do ls, you will notice that the AWS PEM file is available here. If the PEM file is not available here, you will not be able to perform the next command, which is very, very important. That is, I will not be able to log into any of these instances. I need to log into one of these instances because I want to install the Python application in one of the instance first. Okay, so take the private IP address. SSH -i AWS PEM file, Ubuntu @ private IP address. See, I am able to log into this specific instance with the private IP address 10.0.140.109. 10.0.140.109. Perfect. So that means now I am able to log into the private instance as well. I mean, what is a private instance? EC2 instance in the private subnet. Awesome. Now all that I'll do is install the Python application here. So very simple Python application. Let me do one thing. Let me create a HTML page as well. Index.html. So let's pick up a very simple HTML page. W3 schools, HTML basic. I'll pick up a very random example. Let's take this one. Copy this entire thing and put this in my file so that I just want to host this file. Let me say that my first AWS project to demonstrate apps in private subnet. Okay, let me remove this. And now save this file and just run the Python server using Python 3 -m http.server on port 8000. Okay, let me run it on port 8000. So my application is running in one of the instance, that is 10.0.140.109. So what I've done till now is I've used the autoscaling group. Perfect. Let's go back to the diagram. I've used the autoscaling group, created the EC2 instance, created a Bastion host, logged into only one of the instance. So see why I've logged into only one of the instance, because while using load balancer, I want to demonstrate that traffic is going to one particular instance. It is hitting and giving you back the response. Whereas when it goes to the other particular application in a different subnet, it is giving you an error response because this page is not available or the application is not available. Okay, so for that purpose, I have installed Python application in one EC2 instance and I did not install in other EC2 instance. So this is an effective way of explaining you the load balancing concept. Okay, we will see 50% of the traffic should go to one instance, you should get the response, and 50% of the times it should go to other and it should not get the traffic. Perfect. Now what I'll try to do is create the load balancer and attach these instances as target groups. That will be our final stage. So again, let's go here, search for load balancer or go to EC2. That's a easy way. And in the EC2, you have load balancers. So there are three different load balancers. Now you don't have to worry about it. What is application load balancer? What is network load balancer? Classic load balancer, gateway load balancer. We will come to that when we discuss about load balancer topic in detail. That will come after day 20 or something. So don't worry about it right now. Let's go with the default. That is the application load balancer. Not default, I mean. Let's go with this one. Click on the create button. And what is an application load balancer? On a high level, it does the HTTP and HTTPS, which is L7 load balancer, layer 7 load balancer. So provide the load balancer name. Let's call it as AWS prod example. The load balancer should always be internet facing. It should be in the public subnet, right? So we have discussed this multiple times. Load balancer should be in the public subnet and should have access directly from the internet gateway. IPv4 makes sense. What is the VPC that you want to provide? So you know what should be done. Provide the VPC that you have just created. In which of the availability zones? Just pick up both the availability zones, no problem. And it should be with the public subnet, right? So change to the public subnet. Even if you put that in a private subnet, AWS will give you an error. So put both the subnets, both the availability zones, and put the public subnet range. Now the security group, you can select any security group, does not matter, like, or you can create a new security group as well. What you are trying to do in a security group is for the load balancer, are you allowing all the traffic or not? Or in the VPC where the load balancer is there, are you providing access where in the security group you can define, okay, open port 80, open port 8080, whatever it is. So whatever I have attached here is the default VPC. You can remove this one. The VPC for AWS prod example and launch wizard. So if it does not work, what we can do is we can create another security group and we can attach that another security group here, so that what will happen is load balancer, which is listening on port 80, should be accessed from the internet. What is this security group doing? It is allowing SSH traffic and port 8000 traffic. What is this doing? I'm not sure. I need to look into this security group. So let me remove this as well. For now, just add this one. And if it does not work, I'll go to this security group and add port 80 as well. Listeners and routing. Okay. So you need to create a target group where you will define which instances should be accessible. So create a target group first. Just like launch template, firstly, we'll create a target group. And what is the target group? EC2 instances. So which EC2 instances do you want to access? Target group name, just provide AWS prod example. Perfect. And what you are trying to do is you are trying to use the HTTP protocol only to the instances. This is the VPC. Perfect. Health check, HTTP. Perfect. Move to the next tab. Select the instances. This is one instance and this is the other instance. One instance has the application, other instance does not have the application, but it is perfect for the demo. Later, you can also add the instance, add the application to that instance and see that the traffic is flowing. You can try different things. In one, you can say, hi, this is Abhishek. In one, you can say, hi, this is Veeramalla, and see how the load balancing is happening. Targets, perfect. Include as pending. Now create target group. Okay, so if you have noticed here, what I'm trying to do is I have misconfigured. I said that the target group on port 80. So I need to just go back. There is no problem. Go back to your application and just change the port 80, right? So the application that is running, I can just simply go here and run the application on port 80. The reason is that I have misconfigured, or just keep it like this and create the target group. Just modify the target group. This is the one, right? So what you will do is go back to the target group, and here where you have option for targets, this is the port. I'm saying on port 80, but actually the port is 8080. So let me delete the target group, no problem, and recreate. Create target group. Instances, let me do it very fast. Target group name, AWS prod example. Just say port 8000 where I'm trying to access. HTTP1, VPC, prod VPC. Health check is fine. These are the instances which I'm trying to access on port 8000. Perfect. Click on create target group. Oh, sorry. Just include as pending below and click on the create target group. Now the target group is getting created. So just wait for 1 minute here as well. And what is this target group doing? Basically, it has two EC2 instances, which it is uh, verifying on port 8000. Now I'll just go back and add this target group to the load balancer. You might not find it at this point of time. Just wait for a minute or do the configuration one more time. Okay, go to the load balancers, create load balancer, go to application load balancer, create AWS prod example, internet facing, yes. Click on the VPC, prod example, both the subnets and both the subnets using the public thing, right? And then the security groups, like I told you, firstly, let me put one security group. If it does not work, I know what to do. Because I'm accessing the load balancer on port 80, I can simply open the port 80 in the security group. Because I'm accessing the load balancer on port 80. Prod example, perfect. Or I can access the load balancer on port 8000 because I know this particular security group is exposing port 8000. But okay, for the purpose of video, just to show you how this thing exactly works, I'll just use the port 80, which is default. Add-on services, load balancer tags. You have used the target group as well. Everything is looking fine. Create the load balancer. Load balancer is created. View the load balancer. It will take again a minute. So wait for a minute here for the load balancer to provision. And once the load balancer is provisioned, let's try to access it from the outside world. The expectation is when you access the load balancer from outside world, you should see that load balancer gives you a response of the application. So let's wait for a minute here. So now the load balancer is in active state, right? So all the configuration is created at this point of time. And what I've done intentionally, I did not create application in one of the servers, right? But all the other configuration is completely created. I have load balancer, internet gateway, public, private, all the things are available. Now, let me go back to the load balancer and try to access the load balancer. You will see that the load balancer is not accessible because the subnet that you have attached to the load balancer does not expose port 80. I've already told you. So let's see that in practice. So even if you go to the load balancer, you will notice an error. So just scroll down, you will see that, okay, it says that the port 80 is not reachable. Why? Just click on this. It will say security groups for your load balancer don't allow traffic on the listener port. So what you need to do is either go to the security group. So this is a security group, right? Click on this security group, open it, and allow the HTTP traffic on it. How do you do that? Just go to the inbound traffic rules, edit inbound traffic rule, add a new rule called HTTP, open port 80, perfect. Anywhere from the internet is fine. Save rules. After a while, once this configuration is reflected, you should see this error will disappear. What is this error? The listener, where you will see this should disappear. Okay, so it might take a minute. Perfect. Now it is reflected. Now let us access this particular IP address from the internet and see if I'm able to access my first AWS project to demonstrate app in private subnet. Congratulations. You have implemented your first AWS project and you have demonstrated a very complicated project, the project that is used by most of the engineers as DevOps, I mean, most of the DevOps engineers in their organizations. We have implemented this entire concept. Again, like I told you, I have intentionally not deployed in one of the instances. So sometimes you will get an error. Okay. So if you see here carefully, what is happening is the page is not getting reflected. Let me do it in two different tabs. Okay. So, okay. The reason why it is going is there is a target group here, which is actively monitoring the healthy parts. So for example, this is a target group, right? So what is happening here? This target group, which I've created, has a health check. Okay. And it is only forwarding the traffic to the healthiest EC2 instance. So one is healthy and one is unhealthy. So what is happening is the load is always going to the healthiest EC2 instance. Okay. So in future videos, I'll show you, don't worry, where I will configure this health check in a way where it should send irrespective of the health check. Like, you can disable this health check and send that send traffic to the both EC2 instances. But for now, perfect. You don't have to bother about it. The project is demonstrated. And what you can do to see the load balancing concept is go to the other EC2 instance, right? So we have created two EC2 instances, right? In one of the EC2 instance, I created Python application saying, this is my first AWS project. Go to the other EC2 instance in the same way that I've explained and call this as, this is my second AWS project. Okay. Deploy the application, deploy the HTML page with my second AWS project. And now when you hit the load balancer, once you should see my first AWS project, and second time when you hit, you should see my second AWS project. Okay. Because that time both your EC2 instances will be in a healthy state, and target groups will forward one request to one EC2 instance, other request to other EC2 instance. So this is your assignment. Try to do it and let me know in the comment section if you were able to perform the assignment or not. Thank you so much. We'll meet in one more interesting episode of AWS in episode 8. Thank you so much. See you all. Take care. Bye.